Hi, and welcome to Microsoft Virtual Academy. I'm Chris Randall. I'm here with Mike Fall, and we're here to talk about PowerShell for the SQL Data Professional. In this demo-heavy presentation, there are not a ton of slides. Mike is going to help us understand why we as SQL people would want to use PowerShell. It's been around for a long time, but what can it do to us and for us as administrators of on-premise SQL Server, hybrid scenarios, or Azure SQL DB? So let's get started. Mike, why don't you introduce yourself?
Well, thanks, Chris. It's good to be here. My name's Mike Fall. I'm a SQL Server professional, SQL Server DBA. Been doing it for a fairly long while now. Working with SQL 7.0 first, and then on through the years. And sometimes I look back and I go, "Wow, it's really been that long."
I know the feeling.
But yeah, I speak at SQL Saturdays. I do a whole bunch of different stuff with the community. And I've been doing a lot with PowerShell for the past 2 years. Working a lot with PowerShell. Really enjoyed it. A bit of a dirty secret. For a while, I was an Oracle DBA working in Linux, and that was when I came over to Windows again. It was like, oh my gosh, I've got this shell scripting language that I can use, that I can leverage to do so much. So it's been something of a long journey for me, but here I am, doing some great stuff with PowerShell, and hopefully can tell more people about it here today.
All right. Well, let's talk about what this course is all about. What's your agenda?
So we have 3 modules to go through. We have, first off, PowerShell Basics. So we're going to talk about just kind of the fundamental structure of the language, how it's used, how it's constructed, how people can learn about. One of the cool things about PowerShell is it was built with the idea that you could learn about PowerShell while using PowerShell. So we're going to cover that in this first module. Next up is then, where do PowerShell and SQL Server meet? What's kind of that in the Venn diagram of these 2 languages? How do we find that middle space? Because there's a lot of strength there. There's a lot of flexibility and robustness. Then once we get done with that, obviously the cloud is the future, right? Everything's moving to the cloud, whether it's you have a hybrid model, whether you have just a strictly pure cloud model, whatever you're going to do, we're moving to Azure. It's happening. And PowerShell is built as a fundamental component of the cloud, of Azure. And so we want to look at how we can use PowerShell to spin up Azure VMs, Azure SQL Database, and how we can make use of that whole model.
So if I'm a SQL DBA who's going to learn PowerShell to work with on-premise SQL Server, is that going to give me a running start toward learning how to use it against virtual machines or against Azure SQL?
Oh, yes, absolutely.
Cool.
Absolutely.
All right. Well, let's dive in. We've got module 1 is your PowerShell Basics.
Sure thing.
What are we going to do in this one, Mike?
So PowerShell Basics, like I said, we're going to talk primarily about the language and from a general perspective how it's used.
Right.
We're going to be looking mostly around where did PowerShell come from? How do we write it? What are the tools available to us to work with PowerShell, to write with PowerShell, how to create our scripts, and how to debug our scripts. There's all sorts of work in there as well. Commandlets. So commandlets are kind of a cool thing, and it's this piece of functionality. Sometimes it throws people off, but really it's just functions that are the building blocks of PowerShell. We're going to talk about the object-aware nature of PowerShell. So PowerShell is kind of cool versus some other scripting languages where it realizes that objects are out there. It has some relation to object-oriented programming. I don't think of it as object-oriented. I think of it more as object-aware, but we'll get into that. And then pipelining is a nice feature of scripting languages that allow us to extend out functionality and really leverage this robustness of, okay, well, I like to think of it as I can do anything in PowerShell in one line.
Right. So that's where I can take the output of one command, pass it as the input of another, let that do its magic, and pass that on to a third.
Absolutely.
Cool.
Absolutely. Cool. So that's really the overall, this is what we're going to do in this first module. Right. So with that, do you want to just dive right in and go with the first module or first lesson?
Yep.
Okay.
So what is it? What's PowerShell?
PowerShell is a scripting language, right? But it's more than that to me. It's a framework. It's we can write scripts in it, but because there are so many hooks into it, so many ways to use it, it's more of this overarching framework that we can build automation and tasks into.
But it is its own language, right?
It is its own language,
of PowerShell.
It is absolutely its own language. Now, it was first released back in November 2006, so it's actually been around for 10 years, and I don't think people quite realize how old PowerShell is. But it's been a little slow to adoption. particularly I think in the SQL Server world. That's why I like to talk about PowerShell so much in the SQL community, because most SQL Server folks are like, oh yeah, I've heard of PowerShell, but I'm not quite sure what to do with it.
So here's an objection I've heard.
Sure.
You get an experienced SQL DBA. Yeah. They know T-SQL inside and out.
Oh yeah, absolutely.
Why are they going to bother learning another scripting language? Why can't they just do it all in T-SQL?
So the thing about PowerShell and T-SQL, I've heard this kind of people making this case a lot, is, well, I can do it in T-SQL. Why would I do it in PowerShell? PowerShell is not a replacement for T-SQL. Okay. PowerShell is not something that, I'm going to use PowerShell instead of T-SQL. We're going to use the two in conjunction, right? We're going to use PowerShell and T-SQL together to accomplish automation and tasks across multiple SQL servers. So that's really the key thing, I think, for people to understand is it's not one or the other. It's both together. It's both together. Now, one thing to call out, I always like to call out this. So Jeffrey Snover here at Microsoft is actually the guy who, he and his team came up with PowerShell back in the day. And he wrote this really cool document. If people really wanted to get into the geek and the techness of it, the Monad Manifesto is where he really first came up with the idea. And he wrote this back in 2002. But it's this document that kind of lays down the fundamental principles of what PowerShell is and what it's about.
Would you recommend that people read it today?
Oh, yeah.
So we should probably put a link to it in the MVA.
Yeah, absolutely. Cool. Absolutely. We should do that. Okay. Now, the last piece here, too, is the current version of PowerShell is now at 5.0. It just came out a couple months ago, and it's got every version of PowerShell comes with a whole bunch of new features, new functionality. There's a lot of new stuff in it. I always, whenever I'm talking about any sort of tools, whether it's Management Studio, PowerShell, what have you, it's always, please use, try to use the current version. I shouldn't say please use, but try to use the current version, because you're going to get all that new functionality. And the nice thing about what Microsoft does is they make a lot of their tools backwards compatible. Right. For example, I've used Management Studio 2014, but I've used it to manage SQL 2000 servers and SQL 2005 servers. Right. So, if you're going through this course, I highly recommend you get Windows Management Framework 5.0, get the most current version of PowerShell, and you'll be able to follow along pretty well.
So if I'm in an organization that's using SQL Server 2012, or we haven't yet moved to 2016, but we're planning on it, I can still get on the PowerShell train, learn it against 2014, and be ready for 2016. Yeah,
and in fact, I'd absolutely, even if you've got 2012 servers, 2014 servers, 2008 and 8 R2 servers, install the most current version of PowerShell, certainly on your client tools, wherever you're running your client tools from, and you'll be good to go.
So why? Why bother?
Why bother?
Get back to my question. So I'm a T-SQL guy. I've been using T-SQL for longer than I want to admit. I understand PowerShell's got some cool things, especially administratively. Yeah. And when I start talking about Azure, for example, I'm talking about managing virtual machines and virtual networks. I'm talking about managing SQL databases and Azure SQL logical servers. So I get that PowerShell's got some hooks there, but I can get around in the portal. I can get around with Management Studio and T-SQL. What does this do for me?
So there are 3 reasons that I usually focus on for why people should use PowerShell. The first is, and this is to me the most important thing, is I use the term cross-stack. PowerShell is built not with one specific aspect of Windows in mind. It's built with all the different parts and pieces of Windows. When we're working with stuff, we're not just working with SQL Server, we're working with the operating system, with the file system, with Active Directory, with IIS maybe, what have you. So PowerShell, again, because it's a framework, because it covers all these different aspects, we can use it to run tasks that touch the file system and SQL Server and Active Directory maybe, whatever. A use case example I like to touch on is backups. When we do a SQL Server backup, if we run it just through T-SQL, if the file system directory that we want to back up to doesn't exist, it throws an error. Right. So PowerShell is great because it can natively go in and say, well, I'm going to create your directory, and we're going to see this later on in the lessons and then in the demos. But we can do all the file system work with PowerShell, then have PowerShell call the T-SQL statement to execute the backup, and then maybe do some other file system tasks to clean it up. There's innumerable examples of how we can work across the stack, and that's really the one of the big things about PowerShell. The second thing is it's enterprise ready, and that sounds a little marketing, a little fuzzy, but what that means to me is when we're administering servers, most SQL Server DBAs are not administering 1 or 2 or 3 SQL servers.
Right.
We're administering 10 and 50 and 100 and sometimes thousands of servers. PowerShell is designed from the ground up. I mean, Snover and his team were like, look, we know administrators are not working with just 1 or 2 servers. They're working with large enterprises. So PowerShell is built from the ground up to say, I'm going to be able to execute the same way across multiple servers. So that multi-server execution is huge to me. That means I'm running one task once in the same way across all my different servers. And that's a key component of automation, right? That's a key facet. The third thing is it's built on .NET. Back in the day, again, Snover and his team, they said, we're going to build this on .NET. And why that's important, this actually goes back to the cross-stack piece. Because all of the Windows tools access Windows, access Microsoft components and applications through .NET libraries, PowerShell is accessing everything in the same way. The example, again, for SQL Server folks is, and we'll, again, cover this in the demos, if you're using the Management Studio, you're using SQL Server Management Studio, you're using .NET libraries to access SQL Server. So PowerShell works in the same way. It's a way for you to actually interact with all the tools and all the components in the same way as all your GUI tools, all your graphical user interface tools.
All right, so it sounds like with what you've said there, with it being across the stack, and that's really useful in situations where, again, as in Azure, I've got to set up and manage firewalls, I've got to set up and manage virtual networks, my VMs, and then SQL Server within that. Right. We've got that span across the OS and networking into SQL itself, and that kind of takes you into what you're going to talk about next, right?
Right.
The usages and sharing and collaborating with stuff.
Right. So the next piece that this all kind of blends into is it gives you a common framework. And it's not just a common framework for DBAs, for database administrators. It's not just a common framework for developers or sysadmins. Everybody has some. If everybody has an understanding of PowerShell, we can hand these scripts around. And using the sysadmin example, I can write a PowerShell script. Say, for example, I write a PowerShell script to install and configure SQL Server in the way I want it. I mean, I know I can sit down and say, okay, somebody bang out the click. Yeah. But if I hand them a script with a couple calls and it interfaces with ways that SQL Server is already used to set up and automate that, I can hand it to a sysadmin or I can hand it to a junior DBA who may not have the level of knowledge that I do and just say, look, run the script and call me when you're done. Sure. Call me if there's a problem.
Right.
And this also feeds in, I mean, I'm one of those people, I'll fully admit that I'm a lazy DBA. I am a lazy DBA. And this takes away a lot of the tedium of the work, right? I can, again, write this composite script, hand it to somebody who doesn't have the level of experience and knowledge that I have, and say, yeah, go ahead and run this, and call me if there's a problem. And that's going to handle 90% of the work. And, so that's why, to me, the common framework for automation of using PowerShell is again, another huge advantage.
All right. So, well, a little confession for me.
Sure.
Even though PowerShell's been around 10 years and I've been around SQL Server longer than that,
yeah.
I first got my deepest exposure to PowerShell through SharePoint, which sounds a little strange, but I was doing a lot of BI work back when I was a BI consultant before I took this role at Microsoft. And so I was spending a ton of time configuring PowerPivot, which is incredibly lengthy and detailed and all the pieces you got to get. And so I really rolled up my sleeves and got into scripting that through PowerShell and then realized, well, I probably should have been doing this with SQL Server all along. So now I'll probably learn the right way to do it. Okay, well, that wraps up our first lesson. Good intro to PowerShell. Let's dive into our next lesson after a short break. We'll be right back. All right, well, welcome back to our second lesson in this module on PowerShell basics. So, Mike, you've given us the background of PowerShell and why we should use it. How? How do we use it?
Yeah, how is always the trick, right? How is always the trick. So to get started with PowerShell, really we need to talk about the tools. There's a couple things that are available to us within Windows that we can use. And really we need to think about the use cases. So first off is ad hoc command line use, right? Just jumping into a command line somewhere and hacking out some PowerShell and calling something. But the second, of course, is once we start getting into PowerShell and we really start automating things, we're going to need to be using scripts. And I always like to call out at this point that anything that's a PowerShell script is going to be having that .ps1 extension. There's a couple other extensions in use, but for basic script files, you're always going to see that .ps1.
So this is a successor to our old .cmd, .bat.
Yes, yes, yes. And there are two different interfaces. So we have the PowerShell command window, which looks very much like the previous command window, cmd.exe, but has all the PowerShell functionality baked into it. And then we also have the PowerShell integrated scripting environment, or the ISE, which is more of a development tool, right? So we get scripting window and command execution. And again, we'll talk about that more in the demo itself. So I always like to call out these two pieces and parts because this is something of a fundamental concept with PowerShell. So we have the command window here, and we have the ISE. And don't worry too much of the text that you're seeing on the screen. This is just more or less to get familiar with what these look like. But in PowerShell, these are referred to as hosts. It's a front end. It's a development tool, or it's a way that the scripts and the commandlets and the functions are all executed. And it accesses what's called system.management.automation. It's a DLL. It's a .NET library that is what really runs all the PowerShell magic. And what's kind of cool about this is we talk about the command window here and the PowerShell ISE as being hosts. Anything can be a host. Any .NET application can be a host. So you'll see as Windows develops and as a lot of the teams build tools out, they're building their own GUI tools, but they interface with PowerShell. They interface with the system management automation. There's also plenty of other development tools out there for PowerShell, and those are also hosts. Well,
so can SQL Server Management Studio, SSMS, run PowerShell?
It can't right now, cannot.
Okay.
But it might. The SQL Server tools team has done a lot of great work over the past year, and there's a lot of stuff coming into play. So who knows? It might very soon here.
Okay.
So with that, I think we're ready for a demo.
Sounds good. Let's take a look at a demo.
All right. To use PowerShell in Windows, we're going to use one of two applications. We're either going to use the PowerShell command window or the PowerShell integrated scripting environment, ISE for short. To open these applications, you can click your Start button or press your Windows key and select All Apps. In here we have a Windows PowerShell folder with 4 different applications. We have the PowerShell command window and the PowerShell command window's 32-bit version. We also have the ISE and the 32-bit version of the ISE. Now for ease of use, I've gone ahead and pinned both these applications to my taskbar. So let's go ahead and open up the PowerShell command window. When it opens up, it should look pretty familiar. We've had these kind of command windows in the past. This is different because it has Windows PowerShell in the title bar, and it has PS at the command prompt, indicating that we're in PowerShell. Other than that, it works pretty much the same as the command windows we've had before, the cmd.exe. I can type a command such as ipconfig, and it will give me the same output, network adapter information for my server. However, we are in PowerShell. This means we can make use of PowerShell specific commands. I'm going to call a PowerShell system variable called PS version table. What PS version table will show us is what version of PowerShell is installed. So as you can see, we have 5.1 installed. We also have some other information, such as compatible PowerShell versions and the Windows build version. PS version table is a handy system variable that can help you identify what's going on in your environment, how it's configured. We can also run PowerShell commandlets. Now we will talk about commandlets in the next lesson, but for the purposes of this example, I'm going to call the getDate commandlet. GetDate will show us the current date and time of the system. By hitting enter, as you can see, we get Wednesday, June 8th, 2016, 9:51 in the morning, the current date time. This is the most basic way to use PowerShell in the Windows environment. We can run ad hoc commands, we can call scripts. However, there's another way. We had talked about the integrated scripting environment. So let's go ahead and exit
and then open up the integrated scripting environment and see what that looks like. As you can see, we have a full-featured Windows application with a toolbar at the top, some icons for certain actions. What we have next is we have what's called the scripting pane within the ISE. This is where we can write PowerShell scripts, edit different commands, and run them all as a single script. Below that, we have the console pane. Now, the console pane works very much like the Windows PowerShell command window that we were just in. We can run a command such as ipconfig, and it will give us the same output. So we can use our same ad hoc command line execution from the console pane if we need to. However, what we really want to be doing is working with scripts. So I'm going to go ahead and open up a demo script which has a few simple commands. The first line is a comment line. Comments are noted by the pound or hash sign in PowerShell. They aren't actually run, they're just there for comments, notations, what have you. The next line is our PS version table call, and then we have on line 3 our get date call. If I want to run this script in its entirety, I'll press the green arrow, and this will run all of my commands at once. You'll note that we have the PS version table output, just like we had before in the command window. We also have our get date information. Now you'll notice it's formatted differently, and this is a function of having all the commands run at once. PowerShell is trying to identify a format that it can use across all your commands. If we wanted to just see the individual execution of the commandlet, we would select get date individually and press this green arrow with a box behind it, and this will run only the immediate selection. When we run it, as you can see here, we get Wednesday, June 8th, 2016, 9:53 in the morning. We only get that one line of execution. So this application gives us a good way to work with PowerShell scripts to edit our scripts and get entire sections of code to run. We can still use the ad hoc functionality within it. There's also some customization that we can do of the integrated scripting environment. These 3 buttons here help us lay out the script pane and the console pane together. With this first button selected, as you can see, we have the script pane on top and the console pane on the bottom. If I want to, I can click the second button, and what this will do is move the script pane to the right and the console pane on the left. The last button will maximize the script pane and take up the entire view. If I ever want to see the console pane from here, I'm going to click this little arrow in the upper right, which will hide the script pane and show me only the console pane. So you have several different options to arrange how you want to edit your scripts.
So there was the demo on using the different PowerShell tools, the command window and the ISE. So that's really where you get started. That's the beginning of everything.
And so now we need to figure out what to put into those
yes,
commands, right?
Yes.
It's all about commandlets.
Absolutely. It is all about commandlets. So commandlets are, it's a funny term that people are like, they're not quite used to. And what people are probably seeing right now is this big wall of text, right?
So take all of that, put it into 2 words. If you had to describe a commandlet in 2 words only.
Well, really what a commandlet is it's a function.
Right.
That's really all it is.
Okay.
The reason that the commandlet term was chosen specifically was it was something that the Windows PowerShell team, when they're putting the language together, they said, we want people to be able to find our functions when they're looking for help, without getting cluttered with everything. Because if you do a search on a function, you might be getting Java, you might be getting C#, you might, whatever, right? There's all sorts of functions out there. So CMDLET, commandlet, was a term chosen specifically so that people who are looking for help could find it on the web, could find it without it getting cluttered up with everything else.
Is that because only PowerShell was calling things commandlets?
Exactly. It's a unique term chosen by Microsoft, Snover and his team, to say, okay, this is what we're using for PowerShell. Now, what it really is
2 words. I want my 2 words.
A function. A function.
Not those.
Yeah, so it's really, like I said, it's the basic building block of PowerShell. Everything that you do somehow boils down to a commandlet of some sort. And this is where the syntax of it is kind of interesting. So the syntax is this verb-noun structure. Anytime you see a PowerShell commandlet, you're going to see a verb such as get or remove or set. And that's an action, right? That's something that we're doing. And then the other is a noun and what we're doing it to. Now, the verbs are restricted. The verbs are standardized by Microsoft so that you know you're only going to be using a limited set of syntax or pieces of language. Now, what's interesting about that is, how do you find out what your approved verbs are? You run get verb, right? So you're already using commandlets into the language. And this is one of the cool things, is the language starts to become intuitive in how to figure out where things are. Now, the verbs are restricted, but the nouns are, anything goes. And you want the nouns to be somewhat descriptive.
And they're going to be context sensitive, aren't they?
Yeah, exactly.
So in Azure, I'm using nouns like subscription or account.
Right. Well, and I have some examples here of what a commandlet looks like. So the first one, like get date, right? Obviously, get date, right? Get whatever the current date is. Now, get date will do some other things as well. It will, allow you to get specific dates depending on what you pass to it. But at a foundational level, tells you they're going to want to get the date.
So in SQL Server terms, if I run the get date function,
right,
in SQL, that's going to return a date, but it's also going to be a typed return. I'm going to get that as a date type.
Absolutely.
Does something like that happen with PowerShell?
Yeah, so we're going to actually talk about that in, I believe, the next lesson.
Okay.
But yes, PowerShell objects are strongly typed. So everything's an explicit type of, whether it's a date type or a integer type, or there's even SQL Server types. And again, we'll talk about that as we go. Now, another example is new item. So new item is creating a new item, a file or directory. It actually can do a lot of other things, again, depending on what your arguments are, but it's new something. And then finally, remove module is another example. And what does it do?
Yeah, help me understand. I see module a lot in the context of PowerShell. If I open up a PowerShell command window and I try to issue SQL Server or Azure commands, sometimes I get an error that says they're not found in my current module. What is that?
So modules, and again, you'll see a lot more of this, particularly when we get into the SQL Server section. Modules are ways to extend PowerShell functionality. So you have a core set of functionality, but maybe you need to work with Active Directory, you need to work with failover clusters, or you need to work with SQL Server. So you're going to add these modules to extend your functionality. Now, there's some cool stuff with PowerShell, like with PowerShell 3, version 3 and forward, they added this functionality that if the modules are installed in specific paths and you call a commandlet that's in that module but isn't necessarily loaded, PowerShell will automatically load that module for you. Okay. It works most of the time. I'm not going to say it works all the time, but that's a good start. I always like to explicitly load my modules. Well,
that makes sense. That way you can run on a machine that isn't configured the same way as yours. Okay, that makes sense.
Now, I talked a bit about the self-discovery aspect of PowerShell. So this brings me to what I call the big three. Whenever I'm giving this presentation at a SQL Saturday or a similar presentation, I always say, if you don't remember anything else, remember this slide.
Okay.
Get command, get help, and get member are the three most important commandlets. And the reason why is because they give you the ability to drill through the language, to discover things, to learn things. Get command is a dictionary lookup. It's a way for me to say, okay, I want to find what my commandlets are. And in the demo, we'll see how we can use that to explore for some stuff. Get help. The Linux guys always get a kick out of this because in Linux, you're probably used to using man pages, right?
Right.
Get help's the same thing.
Sure.
It's just in PowerShell. And in fact, it aliases to man, to MAN. And then get member, we won't really talk about too much in detail here, but when we start talking about the object-aware nature of PowerShell, get member is a way that we can explore the methods and the properties, the objectness of the PowerShell variables and objects and such. So these are, like I said, if you don't remember anything else, these three commandlets will help you find out anything you need to know about PowerShell and help you learn the language.
So get command, get help, and get member.
Absolutely. Absolutely.
Can we get demo?
We can absolutely get demo. Get demo, this is a great time. This demo will actually show commandlets, how to explore them, and we will go into use cases of get command and get help.
Let's take a look.
All right.
As previously discussed, commandlets are the core piece of functionality within PowerShell. Pretty much everything you do is going to have a commandlet associated with it. Now, the construction of commandlets is pretty important, this verb-noun syntax. What this is something that allows users of PowerShell to find useful commandlets for what they want to do. The basic example is using getDate. Now, we've seen the getDate commandlet before. This construction of it should make sense now at this point. We're going to get date. The construction, the wording of the commandlet in and of itself tells us exactly what it's going to do. So if we run it, it will give us the current date time, Wednesday, June 8th, 2016, 10:47 in the morning. Now, with considering these verbs and the standardization of them, we might want to say, well, I want to see a list of all my verbs. Of course, to do this, there's a commandlet called getVerb to get all the available verbs to us. And if we run this, we'll get a list of all the different verbs and the different areas of functionality they're associated with. Now, there are quite a few, and we're not going to really go through them. But if you ever have a question about what verbs are available to you and what you should be looking for a specific command, you can use getVerb to see what those are. Now, get command is one of the more important commandlets in PowerShell and one that you should always remember. It's a dictionary lookup. It's a way for you to look at the commands available to you, the commandlets available to you, and pull them up. So I'm going to just call get command to get an entire listing of all the commandlets that I have installed. You'll note that there are quite a number of them, and we have a lot of information as this flies by us. Commandlets, the names of them, the versions, and the module that they're installed with. If we hide the script window and just scroll up for a bit, you'll see that there are many commandlets. So you have different commandlets for different areas of functionality within PowerShell. Pretty much anything you can do within the Windows operating system, you're going to have some related PowerShell commandlet for it. Now, if I wanted to filter this lookup to look for only specific commandlets, I can filter on the name. And for example, I'm going to look for all commandlets that have new in the name. If I run this, now we get a list of only those commandlets. So you can see that we have things like new time span and new service and new variable. And there are quite a number of new commandlets. So if you're trying to figure out something that's available to you, using these wildcard searches is a great way to do it. Now, once you've found the commandlet, you want to get information on how to use it, and that's where get help comes in. Get help is one of the second most important commandlets to use. And we just call it simply by calling get help and the commandlet we want help information on. So I'm going to call get help get command. And this gives us, we'll hide the scripting pane for this, a full output on what the commandlet is. So we get a name, a synopsis, syntax for it, so all the different arguments and parameters for it, as well as a full description of it, and some additional information such as related links and remarks. However, there's a lot more information actually available to us. Let's go back to the scripting pane, and now I'm going to run get help, get command with the full switch. When we run this, and let's hide the scripting pane again, we get a lot more information. So starting right from the bottom as we scroll up, there are 14 different examples of how to use get command. So if you ever have a question of what's the syntax and how should I use it, you've got examples baked right into the full help file. As we scroll up even more, we had seen earlier where we had the syntax with parameters. Well, now with the full switch, we can see full documentation on each individual parameter. So we have the type, we have a description of it, whether or not it's required, its position, and a default value if it has one. So lots of information. As you can see though, as we're going through this, it's a little clumsy to read as it all outputs to the console window. So let's go back to the script window, and now we're going to use a switch called show window. If we open this up or run this, then we get a second dialog box with all of our help information in it, right alongside our PowerShell work window. So in this case, we still get the same information, such as the description, the parameters. We can search throughout this if we need to. We have a search functionality. And you have it handy for you to give you any sort of information that you need. We also have a settings box here where we can show certain help sections. So if you only want to see the syntax, say you don't want to see the description or the notes, we can hide those, and now it changes our output. So now we have a way to filter out the help information that we want to look at within the show window. Now there is one more thing to look at, and that is, as I said, all the help information has an online component. It's based from web information that you can update periodically. If you ever want to look at that information, you can use get help, get command with the online switch. If we run this now, it will open up our browser and it will go to the TechNet page of that commandlet. So as you can see, now we have the full web documentation for that we can look at alongside of our scripting window. So multiple ways to get at your help information. There are more than just commandlets in the help system as well. There are topics which start with an about. And if you want to see a list of these topics, you can run get help about star to list them all. And as you can see, we get quite a number of them. We'll hide the scripting pane for this, but to show here we have things that you can look at, such as parallel. If you need to look at parallel execution, there's a topic on that. Variables, if you want more information on variables, you can look at that. Other syntax keywords within PowerShell. So there are lots of options within the help file and the help system to help you learn about the language. But let's go through a practical example. Say, for example, I wanted to create a new firewall rule. I wanted it to open up the firewall rule for my SQL Server. I can say, okay, well, I know there's a PowerShell commandlet for this, so how do I find it? I know it's going to start with new, and I know it's going to contain the word firewall. So I'm going to run get command with a couple filtering items here. So I have new, and it has to start with new, and then I put has to have firewall within the remaining syntax of the commandlet, or the remaining part of the commandlet name. We run this, and it will give us our dictionary lookup, and we get a commandlet that comes back and says new net firewall rule. That probably sounds like what we need. So I want to find out more about it. I want to learn more information, see if it's right for what I want to do. So I'm going to run get help, new net firewall rule, and I'm going to show window. We run this, and it comes up with our help window, all our help information, and we can see the synopsis, we can see parameters for it, any of the additional information we need to see to use the new net firewall rule commandlet. Now, one other thing I want to talk about is aliases. We've talked a lot about commandlets and that everything you do in PowerShell pretty much matches to a commandlet. Let's talk about directory lookups. If I wanted to do a directory lookup in PowerShell, I would use the get child item commandlet. So I'm going to do get child item on the C drive. We'll run this, and we get a fairly standard lookup. Here's all our folders, here's files that I have in the root of my C drive. Now, for most of us working from the command line, if we've been working with Windows, we know we can use a dir or a dir C drive to get the same information. And as you can see, it does come back with the same info. However, what's interesting to note about dir is an alias. Dir is a an alias to the get child item commandlet, and we can see what that looks like by using the get alias commandlet and give it a definition of get child item. This will show us all the available aliases. As you can see, we have dir, which aliases to get child item, GCI, and ls for you Linux aficionados. So if you're used to using the Linux operating system, you can use ls here in PowerShell as well to accomplish the same task. So this overall gives you an idea of how commandlets can be used and how you can look up useful commandlets for whatever task you need to accomplish.
So that was a demo on just using commandlets, how you can explore through commandlets, how you can call up information about them, and hopefully helps people, right? That's the whole point of this course, right?
Right. So, okay, so we've got commands we can use, commandlets, functions.
Right.
Other classic programming languages have things like variables. We're going to talk about that?
Oh, yeah, absolutely. So that's obviously next in the queue.
All right.
Because, any language that you're going to use, any programming language has to have variable support. You have to be able to declare variables. In PowerShell, it's no different. Now, the thing about PowerShell and the PowerShell variables is, particularly when you talk about scripting languages, it's a little different. Now, first off, let's talk about what defines a variable. Anytime you see something with a $sign in front of it in PowerShell, that's a variable.
Okay.
So, dollar food, dollar bar, dollar lunch,
okay,
dollar whatever. Now, this is another thing that I say a lot, and people are like, okay, Mike, we get it. Everything in PowerShell is an object, and this is unique, or I shouldn't say unique, but this is different than certainly Corn Shell or Bash Shell and a lot of previous scripting languages where everything was like a string or a number, right? PowerShell, a lot of its richness and functionality comes because everything is an object. Everything has these things called methods and properties.
Well, so in SQL terms,
right.
Give me an example. If I'm going to be manipulating SQL Server using PowerShell, what are some of the objects I'm going to manipulate?
You see, so that's the thing is it doesn't quite translate to a SQL Server model. It sort of does, because when you have your properties, those are attributes.
Okay.
So let's say, for example, I have a table with columns in it, rows and columns. My primary key has a bunch of columns attached to it with data in there. So we might have our object and have all these properties associated with it that say, okay, here's the other things that define this object. Methods, though, are functions. Methods are specific actions that we can take. And if we look here, looking at the slide on the right, we can see what this actually sort of looks like. So we declare a string variable called t, and I give it the value of hot. Now, this is a system.string, a .NET string variable. And attached to that is some methods, and the methods and the properties. Now, the property here is length. This is an attribute that doesn't change as long as the value of t remains hot, and it's always going to be 3, and we can just call it as an attribute. But let's say, in SQL Server, it would be car index, right? We would do a car index lookup of where the letter O appears. In PowerShell, or in the .NET model, I should say, it's index of. And so it's just a function we call to say, okay, where's the letter O? Because we could call the same function and say, where's the letter T, where's the letter H, where's the letter J, which would come back with a 0 because there's no index value of that. So this is really, to me, one of the key foundational pieces of PowerShell. It's this object-aware model because it gives us this richness of data, really, around our variables, how we're declaring things. So with that, I think we're ready to jump into another demo here to see just how this works.
Sounds good. Let's take a look at a demo.
All languages need some sort of variable support, and PowerShell is no different. Variables in PowerShell are notated with the $sign. In this case, I have a string variable called string with $string as the name of the variable. I'm going to assign a value to it using the equal sign, and the value is this is a variable. If I run that individual line, you'll notice nothing comes back because what we've done is we've assigned the value into the variable. And now if we call the variable itself, we can see what that value is. And there it is. This is a variable. Now everything in PowerShell is a strongly typed .NET object. So every variable we create is not just a string or an integer, it is a .NET object relating to that. We can see that by using the getMember commandlet. I'm going to pass $string to getMember, and we're going to get the output Let's scroll up here and look at this. So the output first off tells us it's a type of system.string. And because of that, we get all these methods and properties. All .NET objects have these additional methods and properties which give us an extra level of robustness when dealing with our variables and the data contained within. So we can call methods, which are essentially functions, on those variables and what are contained within them, or we can look at properties, which are attributes of those variables. Now, as I said, everything's a strongly typed .NET object, and this goes for dates. So let's create a date variable, and we're going to use getDate to create it. We're going to call the current date. We will assign that value, and now when we call that value using the variable, you'll see that we have the date of Wednesday, June 8th, 2016, 12:24 p.m. To investigate what type of object this is, we're going to take that variable and pipe it to GM, which is the alias for getMember. And as we scroll up and look at the output, you'll see that we're dealing now with a system.dateTime object, and our methods and properties are relating to a datetime object, not a string object as we were previously looking at. If we look at that a little more closely in detail, we can call those methods and properties by using dot notation. So in this case, I'm calling $date, and I'm going to look at the day property. I'm going to look at the day of the week property, the day of the year, and then because the date that I grabbed was the local system date time, I want to run a function to universal time to see what my UTC time would be. So we're going to run these 4 lines, and you'll see that our output now is 8 is the day, so it is June the 8th, so there's our 8. It's Wednesday, which is the middle of the week. It's the 160th day of the year, and UTC time is Wednesday, June 8th, 2016, 6:24 p.m. So already we can see that we have a whole additional level of functionality using these strongly typed .NET objects to see different parts of our data and expose different aspects of it. Now what we've been talking with so far is implicit data typing. You'll notice that we didn't declare anywhere in there what type of data it was when we created the variable. We can do explicit data typing if we want to say I want my variable to hold a very specific type of data. In this case, I'm going to create a string variable called dateString, and by using the brackets in front of it, bracket string bracket, we're going to explicitly type that variable as a string variable. And then I will assign the value of getDate to it, which would be the current date. Now if we call the output, call that variable, we will see that the output is 6/8/2016, 12:27, and the formatting is different than what we've seen before. The reason for this is because now we're dealing with a string, and PowerShell is using our regional settings to appropriately assign the formatting to it. If we look at getMember for it using that GM alias, we can see that we're dealing with a system.string object. If we scroll up a little here, we'll just see that again. There's our type name, system.string, and all the methods and properties that would come with a string object. This allows you to control what types of data you're working with if you feel that's necessary. However, most of the time, implicit data typing is going to give you what you need. It all depends on what your use case is going to be. For another example of that everything is an object, I'm going to create a new file. I'm going to use new item, create a item type of file, and I'm going to create it in this path, ctemp, and it's going to be junkfile.txt. I'm going to assign the output of that commandlet to the $file variable. And now if we look at the methods and properties of that file object, you will see that we're dealing with a system.io.fileinfo object. So we're dealing with an entirely different type of object for our file, and this gives us other methods and properties. Let's go back to the script pane and look at some of those properties. Let's say I want to look at the name, or the full name, or the extension, or even the last write time of my file. We'll run this, And our output is, our name is junkfile.txt, the name of the file itself. We have the full name, which includes the path, and we know that it's a .txt extension. The last write time was Wednesday, June 8th, 12:28 p.m. So very quickly we have access to different types of data around our objects. And this goes through the entire scope of the PowerShell language, as everything is an object. We'll clean up this file from our example.
So that should show people how to use objects and variables within the PowerShell language, right? There's some trickiness to it, and I think a little bit for particularly SQL people to get their brains wrapped around, but it starts to make sense when you start working with it.
All right. So you mentioned earlier that one of the other capabilities of PowerShell is a thing called the pipeline, where once we learn these different commands, we can string them together.
Sure.
Let's talk about that.
All right. Well, yeah, the pipeline. So the pipeline is something that's been in scripting languages for a fair amount of time, right? It's been around in, again, the Linux, the Unix the Linux and the Unix environments. It's also been, I'm pretty sure it's in the command window. I'll be honest.
I used it in DOS years ago to pipe things to more so I could scroll the screen.
Right. So the idea is just to extend the functionality, right? To take output from one commandlet, one piece of functionality, pass it to another, and continue to process down the pipeline. I like to think of it as gates, that you're taking information and passing it across the gate to the next section across the gate. And you can do this, I don't want to say ad infinitum, but you can do it pretty far out. Okay. And it really does give you a lot of flexibility to work with the language, to extend what you're trying to do, particularly from an ad hoc perspective. I tend to do pipelining a lot from ad hoc because I can then say, okay, well, I'm going to, for example, I was talking about removing files. I can get a list of files, I can do it to the pipeline, do some additional filtering, and then finally remove it. And I'm all doing that ad hoc, all ad hoc. If I'm writing a script, I don't tend to use the pipeline quite as much because I tend to want to be a little more verbose in my scripts to make things readable. But the pipeline is just, it's huge. You've got to kind of understand it. So I think with that, we'll just dive into a demo and talk about how we use the pipeline itself.
Sounds good. Let's take a look.
The pipeline has existed in scripting languages for some time now as a way to extend functionality of a single command line execution. We've been using the pipeline in some of the previous demos as a way to explore the objects using getMember. To go through this again, I'm going to create a string variable, and then we're going to take that string variable and pass it to getMember. What's really going on here is we're taking the variable and passing across the pipeline to getMember, which is the next command in the pipeline. When we run this, we get the expected output of our methods and properties for a string variable. The next way to use this is with some collections. We know that there are about topics that we can look at in the PowerShell help system, and the way to look at them is to get help about star. However, what we can then do is to see how many there are, we can pass it to a commandlet called measure object. So we're going to get the collection here, and then it's going to be passed across the pipeline to measure object to give us an output. When we run this, the output is 131 for the count. You note we don't see the actual collection, we see the result of the end of the pipeline, which is the measure object. Let's use this on some file system manipulation. I'm going to go ahead and create a sample directory that we can work in. And then what I want to do is take this content, the quick brown fox jumps over the lazy dog, and I'm going to send it across the pipeline to a commandlet called outFile. OutFile is a commandlet that will create files for us and populate that file with the content we pass it. So we're going to take this content, pass it to outFile, and write it to ctest dummy text. And then we're going to use Notepad to open that file up to see what the content is. When we run this, as you can see, we get a dummy file, and there's the content that we just wrote to it using the pipeline. The pipeline can also be used to manipulate multiple things. Just as we saw with the help topic, we saw that we could process it with measure object. What if we wanted to remove multiple files with one command? I'm going to go ahead and create 4 additional files in the test directory. We'll do a quick clear screen and then do a directory on ctest to see what's in there. And as you can see, we have 5 files, the dummy and junk 1, 2, 3, and 4. Now what we can do is that directory gives us a collection of files. So if we run the same directory lookup and pipe it to remove item, we can delete all those files with one action. You see that it doesn't give you any sort of output or feedback, but now if we do a directory lookup on ctest, there's nothing there. This also stresses an additional point. PowerShell is a very sharp knife. You should be careful you don't cut yourself with it. As you noticed, that action we did with the remove item didn't give us any sort of warning or ask for any sort of confirmation. It just simply removed the files. So be careful when you're working with these commands and the pipeline to make sure you don't do anything that you don't want to do. So let's get a little fancier now. One thing that SQL Server administrators always like to know is how much free space is left on their servers. We can do that using one line of PowerShell extended out via the pipeline. There is the WMI, or the Windows Management Interface, and we can use getWMI object to access that. We're going to use that to get the Win32 volume class, which will show all attached volumes for our server. Now we want to filter on that a little bit because we may not want to see all those, so I'm going to pipe that to where object and filter it on drive type equal 3, drive type being a property of the Win32 volume output. Next, I'm going to pipe it to sort object, and I want to sort by the name. I want to look at my drive letters ascending to descending. And then finally, I want to output certain fields with certain formatting. So I'm going to use the format table commandlet with a bunch of other stuff. And don't worry too much about this. You can look at it at a later point. But really what we're doing here is we're just doing some formatting to get the output looking the way we want it to. And when I run this, I have a quick and simple report of how much free space is left on my server. Now I only have one drive on this demo server, but if I had multiples, including mount points, they'd all show up here. The next useful pattern is deleting old log backups, or deleting files in general. One of the things I know we as database administrators can struggle with is sometimes getting rid of older backup files and keeping enough space on our drives for new backups to be written to. What we can do with PowerShell is manage that quickly and efficiently. Instead of having to go through and pick manually through your file folders to find the files to delete, I can get rid of most of my old files with one line of PowerShell using the pipeline. First off, I'm going to do a directory lookup on my SQL Server where my backups are stored. I'm going to use the recurse switch because I want to look through all the subdirectories as well. This gives me a collection of a lot of files. So I want to filter that down, and I'm going to pass it across the pipeline to a where object. And I only want to filter on transaction log files with a last write time older than 3 hours ago. Finally, I'm going to pipe it to remove item, and I'm going to use the what if flag just to say, show me what you're going to do, but don't really do it. When I run this, I get an output of a lot of actions saying, hey, we're going to be removing all of these files. And if I look at the timestamps in the file name, I can see that it's everything that's older than 3 hours ago. So this is a handy way for us to quickly clean out old files, old backup files that we may not want to use. And the important parts here are obviously getting a directory lookup of all the files we want to work with, and then filtering it appropriately based on our extension and the last write time. Now a handy trick here is, as SQL Server DBAs, if we have to delete a lot of records from a database table, one of the things we'll tend to do is run a select statement with the criteria first, and then if that all matches to what we expect, put the criteria into a delete statement. We can do the same thing with the pipeline and the PowerShell commands. For example, if I wanted to run this command and see, am I getting the right files before I actually pass the remove item, I can execute everything up to the last pipeline, so everything previous to the remove item, run it, and get a listing of files. And I can look at those files and say, is that what I wanted to delete? If it is, then all I have to do is add pipe remove item, because I know everything that's going to be passed from this call will be passed across the pipeline to the remove item, and that's all it will act upon. So the pipeline is a very useful piece of functionality that really allows you to flex out your SQL Server and PowerShell commands, everything that you're trying to do across your environments.
All right, so there's the pipeline and how you use it. And like I said, it really does add a lot of flexibility, robustness to using PowerShell, particularly in an ad hoc sense.
All right. Well, so we've learned a ton in this module about PowerShell as a language, as a framework, and we need to get closer to applying that to SQL Server, which we'll do next, applying that to Azure. But why don't we take this opportunity and kind of sum up what we've talked about so far?
Yeah, absolutely. Right. Absolutely.
So what we've seen is that PowerShell is a framework to provide automation across the Windows platform.
Right.
We've talked about it kind of generally that way, and we're going to get more specific to data professionals going forward.
Yep.
Right. We saw that we could use PowerShell inside a command window, or we could use the ISE to write and execute our scripts.
Sure.
We learned that commandlets are the building blocks for PowerShell scripts, and we're grateful that the word commandlet was invented because it makes searching on MSDN a whole lot easier.
Yeah, absolutely.
Right? We also saw that everything in PowerShell is really an object, and that's going to be really useful for being able to take advantage of the types provided.
Yeah, like I said, that is a huge concept that I really want people to kind of embrace, is that .NET object thing.
And then for extended functionality, especially for ad hoc scripting in a command window, the pipeline is a really useful thing.
Yeah, the pipeline is huge. So, that's pretty much it for that first lesson.
All right, well, when we come back, we'll dive into using PowerShell with SQL Server in Module 2. Thanks. Hi, welcome to Microsoft Virtual Academy. We're here for Module 2 of our course on PowerShell for the SQL Data Professional. I'm Chris Randall, here with Mike Fall, and we're ready to talk about using PowerShells with SQL Server.
Yep.
So Mike, what are we going to talk about?
So we've got a couple different things to talk about here. So first off, we want to talk about the SQL PS PowerShell module. So we talked about modules in the previous module.
Right.
PowerShell modules are things that we can extend the functionality of PowerShell out within our session. So there's one specifically for SQL Server, and it's called SQL PS. Then we're going to talk about the SQL Server provider. So with the command line and the way that we're using PowerShell and any other command line operations, we want to interact with things, and usually the best way to do that is as if it were a file system. So the provider gives us a way to interact with SQL Server as if it were just folders and directories and files and whatnot for all the different objects. Then we're going to talk about SQL Server specific commandlets. So commandlets, again, the basic building block of PowerShell, functions that allow us to do things. And there's a set within the SQL PS module that are specifically meant for managing SQL Server and SQL Server operations.
So are we going to be able to initiate backups and restores using these commandlets?
Backups and restores, calling SQL and SQL scripts. Those are kind of the basic functions. There's a lot of functions. In fact, there's a whole section on availability groups that we're not going to cover today because it's a little more advanced.
Sure.
But there's a bunch of different commandlets to execute different SQL Server tasks, yes. Next up, we're going to talk about the SQL Server management objects. So the SMO is a .NET library that PowerShell can interact with, just like anything else. Again, we go back to PowerShell's built on .NET. So the SMO allows us to interact directly with these, to maybe do some more stuff with SQL Server that we couldn't do with the commandlets. Next up, we're going to talk about PowerShell and the SQL Server agent. So I believe it was with SQL Server 2008, when they introduced PowerShell with SQL Server together, they gave us the ability to run PowerShell scripts as SQL agent job steps. So we're going to talk about that.
So instead of using T-SQL as the source of the job, we can use PowerShell.
Absolutely, absolutely.
Cool.
And then finally, one thing I always like to do when I instruct PowerShell to people and show them PowerShell with SQL Server is, what do I actually use this for? What's some practical use cases? So we're going to go over some practical use examples of PowerShell and SQL Server, some tasks that I've automated in the past and how I've gone about it.
And we're going to have lots of demos along the way?
Lots of demos along the way. Lots of demos.
Well, let's dive right into SQL PS.
All right. Well, yeah. So SQL Server PS or SQL PS is PowerShell module. Now, it was introduced with SQL Server 2008 R2, I believe, and contains two areas of functionality, the provider and commandlets. We talked a little bit about the provider and the commandlets already, and this is really the breakout. There's not much more else in the PS module, but these are pretty big areas. Mm-hmm. We load it using the import module SQL PS command. So import module, again, going back to that verb noun nature of PowerShell, import module says we're going to load a module into our PowerShell session, and SQL PS is what we're going to use.
And so once I've done that, I've got access to the PowerShell.
You've got access to all of it. Now, again, kind of calling back, if it's installed to the right path and you have greater than PowerShell 3.0 installed, then you can call a commandlet and we'll automatically load the module for you.
But it doesn't hurt to import it.
I always like to explicitly import modules when possible. Now, the one other thing is it does require PowerShell 2.0 to execute. Now, we're on PowerShell 5, so that shouldn't be a problem, but depending on
2.0 or greater, or you need 2.0 and 5?
2.0 and greater.
And greater, okay.
So one of the things that we hadn't really talked about, but with each version of PowerShell, they've supported all the previous stuff.
Right.
So if you have PowerShell 5, you can support everything back through history. Now, one thing I do want to call out is, some people might see this in the documentation from Microsoft, that SQL PS is being deprecated. So there's a subtle difference here. There's this thing called SQLPS.exe, which is a command line executable that loads the SQL PS module and sets a few other things. Perfectly honest, I really don't use it because I use everything straight up from PowerShell, but it does if you do a right click in Management Studio and you say start PowerShell task, it's going to run SQL PS and get that all loaded. That's going away eventually, right? It's the same with any sort of, whenever something comes up on the deprecation list, you don't know when it's going away, it's just going away at some point.
So we'll just continue to use what we've already started to learn how to use, which is the PowerShell command window or the ISE, import the module, and off we go.
Yes, yes. And I'm only calling this out kind of as a technicality. Now, some people also might ask, well, how do I install it, right? That's obviously a big question. Anytime you install any SQL Server component, you're going to install the SQL PS module, which is kind of nice, but at the same time kind of frustrating because I can't install it separately. I have to install some SQL Server component. Usually, and honestly, right now that Microsoft has broken out SQL 2016 Management Studio into its own release, you can install that separately. As soon as you install the most current tools with the Management Studio, you get SQL PS.
So just to make sure I'm clear on that, the path of least friction to get SQL PS is just to install the monthly SSMS build, right?
Exactly, exactly.
All right.
So with that, why don't we just dive right into a demo here and show what SQL PS is all about, how we load it, how we start working with it.
Sounds good. Let's take a look at a demo.
This demo provides an overview of the SQL PS module. The SQL PS module is the PowerShell module specifically designed to manage SQL Server through PowerShell. To load the module, we're going to use the import module command and call SQL PS as the module we're going to load. Executing this doesn't really give us anything back, but the module gets loaded into memory. We can see what commands are available to us in the module by using git command module SQL PS. Executing this gets us a list of the commandlets, their names, and the version of them, as well as that we're in the SQL PS module. In total, there are 46 commandlets, one SQL Server provider function, and 2 aliases that are used to work with commandlets existing in the provider. We can find out where the module lives on our system by running git module list available SQL PS, and it will give us the full information of the module. So we have our module output as well as a directory, that directory being C, program files, x86, Microsoft SQL Server, 130, tools, PowerShell modules. As long as you use the default location for your SQL Server tools install, this path will remain the same, and you will always be able to find your PowerShell module installed under there. However, if you use a non-standard location, what you will be looking for is this path right here, the Tools PowerShell modules. This will be relative to wherever you install the SQL Server tools. Now there's a couple gotchas to call out with the SQL PS module prior to 2016. If you're using a version prior to 2016, you will get a warning message when you import the module about two commandlets that don't match the naming standard. I call this out because the warning doesn't actually mean that the module didn't get loaded or was only partially loaded. The module gets completely loaded when you see that message. However, it just is telling you if you're looking for specific commandlets, there are two that don't match the naming standard and you might have trouble finding them. Another issue was when prior to 2016, if you loaded the module, it would automatically set your location to be SQL Server, the SQL Server drive. This has since been corrected in 2016 so that when you import the module, it doesn't change your location and leaves you wherever your current working location is. These two items are important because it stresses why you should always be using the most current version of the SQL Server tools. You can easily manage previous versions of SQL Server with the updated version of Management Studio. So I strongly recommend that if you are going to be working with it, you get the most recent version of the SQL 2016 Management Studio and the SQL PS module.
So that was the basic overview of what the SQL PS module is, right? We get the commandlet, we get the provider, we can load it, and that's just how we get started. But there's a lot more to it.
All right, so you mentioned once we've got the SQL PS module loaded, that gives us access to the provider?
Absolutely, absolutely.
Let's talk about the provider.
Yeah, so the provider, well, let's think about it for a bit. You know, we step back and we say, okay, we're working with a scripting language. What does that mean? Well, that means we're doing everything from a command line. We're doing everything from, basically all where we can do is just enter text.
Right.
We don't have things that we can click on, and that somewhat limits what we can do. So the idea is that when you work with a provider, and there's providers for everything, right? There's not just a provider for SQL Server. There's a provider for Active Directory. There's providers for the registry keys. And these providers allow us to get into these parts of the Windows stack, the Windows platform, and work with them as if they were a file system. So we're used to changing directories and drilling down through folders and all that. Well, the provider says, okay, well now we're going to do that, but with SQL Server, we're going to drill down into servers and into databases and to logins.
So your path, I shouldn't say path, your prompt in the command window, instead of being drive letter, folder level, is going to be SQL Server name, database name, table name.
More or less, right? So to get the provider, we're going to go ahead and import the module. And once we do that, then we can do change directory SQL Server. And now we're in the SQL Server provider. We're not in a specific SQL Server. But then we get this, as you said, command line. You know, what are we looking at for the folder path?
Right.
And this is a pattern that this isn't like strictly what we'll see when we would show up. But this is the sort of pattern that all the SQL Server components are going to show up with in the provider. We're going to have the SQL Server drive. That's the SQL Server colon, right? And then SQL is the folder. This is the part of the engine. If we actually, and we'll see this in the demo, there are other components that we can work with within the provider. Okay. But then we'll have a server name or a host name. And then because we can have multiple instances, right? We can have a named instance or we can have the default instance. Then we'll have that folder as well. And you just browse down through that and then into databases or into logins or into tables, so on and so forth.
So coming at this from a T-SQL perspective, I look at this and I think, oh, this would be an interesting way to get a list of all the tables in this database. Whereas in T-SQL, I might do that by querying a system view.
Right. And in fact, the system view, the DMV comparison is very apt because, and some people are going to probably ask that question. They're like, well, why would I use the DMV when I can use this? And we talk about that in the demo. Really, the reason for me is because we can go across multiple servers, and we'll see some of that again. Well, actually, let's just take a look at it right now. We'll just dive into a demo and see how the provider works and how we can leverage it more than just saying, oh, okay, great, I can go and look up a list of tables, right?
All right, well, let's take a look at a demo on using the PowerShell provider for SQL Server.
This demo shows how to use the SQL Server provider a portion of the SQL PS module used to manipulate SQL Server as if it were a file system. Providers are a common piece of PowerShell and exist for many different parts of the Windows stack. To look at all of your providers, you can run git ps drive to display them. As you can see, we get a variety of providers, such as file system providers, which are the normal system drives that we're used to using, such as the C drive and the D drive. But we also get other providers, such as the alias, the environment, and several others. The one we're focused on is the SQL Server provider, which has its own drive letter that we can change into. Changing into the SQL Server drive is as simple as doing a CD. And then we'll do a dir to do a directory lookup of what's under the SQL Server provider. We have several different components all relating to SQL Server. The key point is we're browsing this as if it were a file system, but you'll note some familiar things, such as data collectors, or maybe SQL registration. The SQL Server engine is what we will focus on here, and it is under the SQL folder. And we can change directory into that with just a cd SQL. Now we're also going to go look at a specific SQL server, so I'm going to change directory into the SQL folder and then the folder underneath it for the machine I want to look at, in this case Picard. And then we will do a directory lookup. You'll note that what it displays is the instances installed on that machine. SQL Server can have multiple instances and have named instances. So we have to be careful about what folders are going to be under the machine. In this case, we only have the one, it's the default. So to then browse into that, we would do a cd default to look at the default instance, and then we'll do a directory lookup there to see what's in there. The listing we get is pretty familiar, a lot like what we would see in Management Studio's Object Explorer. We have audits, availability groups, databases, logins, a variety of components that all represent things that we've probably worked with in the past. And again, these are folders that we can continue to browse into as if we were looking at a file system to see what was in those subdirectories. Let's go ahead and look at our databases by simply doing a dir database. Running this brings up one record back for wide world importers and some information about that database. Things that we're probably used to seeing: the recovery model, the collation, and the owner. Now what's obviously missing are the system databases. The reason for this is the way that the provider was implemented was to make all system objects hidden and only displayed if you specifically wanted to display them. To do that, we would use the force switch for our directory. So just like we did a directory of databases, this time we'll do it, but we'll use the force switch. And the result is now we get all of our system databases appearing as well. So this is very useful, particularly for somebody who's used to working from the command line and browsing through file systems. As with everything else, everything in the provider is a .NET object. We can determine what kind of object is by doing the directory of databases and using the get member call to see what kind of methods and properties are available to us. There are quite a few, and once this completes, so what we will do is we will now look at the full console pane, and I want to scroll up past all the properties and methods, and at the top we have a type of Microsoft SQL Server Management SMO database. So we're dealing with SMO objects. Now there will be more on the SMO and the objects that are within it in a later lesson. But the point here to understand is everything in PowerShell is a .NET object, and it's no different with our databases. Because of this, we can make use of methods and properties attached to those database objects. So I'm going to do another directory of databases, but this time using select object, I'm going to show some specific properties. We'll run this, and the output we then get is a listing of our databases, but now we can see when they were created, their size, and when they were last backed up. So we now can make use of this to get even more information about our databases. Of course, a lot of people are going to say, hey, you know, this is just like doing a select from sys.databases. How is this different for me? We're going to talk about that in a bit, but because we're in the provider and using the file system, we get a little more flexibility about looking at multiple objects at once. Now, if we wanted to look at other objects within our database, it's just a matter of drilling down through the folders that represent the different parts of the database. So for example, we know that we have a wide world importers database, so if we do a directory of databases and then wild world importers and then tables, we're going to be able to see all the tables within our database. As you can see, as this listing returns, we get all of our databases with the schema, the database, the table name, and the time that the table was created. So everything here is a way for us to browse and explore our SQL servers from the command line using some simple directory commands and browsing as if we would normally do on the C drive or the D drive. Where this really starts to become useful is across multiple instances and building loops to allow us to process multiple objects at once. I'm going to take an array of my two instances, Picard and Riker, and then I'm going to wrap it up in some PowerShell down here. Now, this is somewhat complicated. I'll let you pick it apart on your own at a later point, but really what's going on here is we're taking a list of our instances, and then for each one of these, I'm going to do a lookup of the databases in that instance, do some sorting on it, and then pull back only specific properties for that list of databases. So let's go ahead and run this. And we get a listing of all the databases across our environment, when they were last backed up, how big they were. This gives us a lot of flexibility for querying across multiple instances, and this is really where the strength of the provider comes to play. Because we can do loops and we can use PowerShell logic across multiple instances with the provider, we're not limited to just pulling one instance at a time. We can very easily pull information across our entire environment. Because to expand this out to even more servers, all I have to do is add their names to the array, and the rest of this logic stays the same.
So that brings us kind of through the provider and how we can use the provider, how they actually interacting with SQL Server as if it were a file system, you know, how that can be advantageous to us.
All right, so we can do that. Now let's tie this back to what you talked about last module, which was commandlets, which really seemed to be the guts of working with PowerShell. You learn what the commandlets are that we need.
Right.
And presumably, you're going to show us some commandlets that have to do specifically with SQL Server.
Yeah. So again, commandlets, fundamental building block. They're functions within PowerShell that allow us to do specific actions. And SQL Server has some of its own. Now there are 46 commandlets for SQL Server 2016, and we're going to go through those a little more in detail. But to give people a high level overview of what these are, you know, they break down into 4 categories. Now, full disclosure here, these are my categories. Okay. Microsoft hasn't actually defined any categories around the PowerShell commandlets, but this is how I tend to think of them. And the focus areas are really 4 different sections. We have general purpose commandlets, things that just do general actions within SQL Server, like running SQL scripts or maybe getting a SQL Server object. And we'll talk more about how everything in PowerShell is an object. We'll talk about how that applies to SQL Server.
Something just caught my eye. Did you say running SQL scripts? So I can take my library of T-SQL scripts and I can execute them from within PowerShell?
Absolutely.
Awesome.
Absolutely.
Okay. Awesome.
Well, and that's the thing, right? So again, we come back and we talk about PowerShell and T-SQL. People are like, well, PowerShell or T-SQL. No, it's PowerShell and T-SQL. And there are commandlets that we can use to wrap around T-SQL, things that we're used to, that we're familiar with, and just execute them in that PowerShell framework so we can run the same thing across multiple servers.
Okay.
So general purpose is one of the focus areas. Cloud management, you know, we talk about Azure, we talk about everything going to the cloud. So there's some specific SQL Server commandlets that are useful for cloud management. Again, full disclosure, I don't use these so much because there's probably better ways to do them, and I think either using Azure-specific commandlets. There are two different teams developing the SQL Server tools and the Azure tools, and so sometimes they're dealing with the same sort of problems.
Sure.
Backups and restores are huge, right? So there's a set of commandlets specifically developed for backups and restores, and not just typical backups and restores, but then we start talking about the Azure aspect. There's some commandlets in there to actually manage what's called the managed backup, where you can set up a backup of your database directly to Azure. I don't think we talk about those quite in the demo, but that's there, and that's kind of cool, and that's the hybrid nature of what Microsoft is moving towards.
And and just to advertise our own products, we will be adding courses on some of those topics as well, and extending some existing courses here on MVA and other sources to touch on these.
Right. And then the final area is availability group management. So there's a lot of commandlets. In fact, over half of the commandlets are dedicated to availability group management. Now, we're not going to talk about that because that's a fairly advanced topic. In fact, I have a whole other presentation I've given before on that, and there's just a lot of information to cover. But I want people to be aware that they're there and that they might want to use them down the road. So with that, let's dive into a little more detail here. Let's jump into a demo and see some of the commandlets, how I've used them, how some practical patterns around them, and what people might be looking for when they look at commandlets.
Sounds good. Take a look at the demo.
This demo goes over how to use some of the commandlets in the SQL PS module. Commandlets in the SQL PS module are intended to manage aspects of SQL Server. We can see the listing of all these commandlets by using git command module SQL PS. And I'm also going to run git command module SQL PS and pass that to measure object just to see how many commandlets we have available to us. We have a big listing of different commandlets. Really, the important thing here is we have 49 different commandlets. The reality is we actually only have 46. 3 of these in the count are, we have 2 aliases and 1 function for the SQL PS provider. So those are included in the overall count. The reality is there are 46 commandlets for different aspects of PowerShell. Now, we're not going to look at all of them. I only want to touch on a couple that are important. We're going to start with invoke SQL CMD. One of the main things to do with any sort of SQL Server interaction is to query the database. Invoke SQL CMD is how we can run SQL queries in PowerShell. The way it works is we're going to have a SQL statement, in this case a statement that does a count of databases by database owner, and then we pass it to invoke SQL CMD. We also give it a server instance name, a database where we want to run the query, and then the query itself. If we execute this, the output is what we would expect. A name column and a DB count column giving us the name of our owners and the count of those databases owned by that owner. So pretty straightforward, nothing surprising here. Now some folks might be saying, hey, I've had SQL CMD, the command line executable, since SQL 2005. How is this different? Why would I use invoke SQL CMD over SQL CMD? Well, let's take a look at that. I'm going to go ahead and take the output of that query and put it into a variable for SQL CMD and then another one for invoke SQL CMD. We run this, and then let's look at the outputs themselves. We'll look at the SQL CMD output first. And it is what we're expecting. However, we get kind of some wonky formatting. We have this word wrap going on. We have the things, because of that word wrap, our rows aren't aligned. So this is somewhat problematic. I mean, we get what we're looking for, but it's difficult to really make use of. Whereas if we run the invoke SQL CMD out, we get a lot cleaner formatting. And the reason for this is let's look at the types of objects we're dealing with. Again, everything in PowerShell is an object. So if we look at the objects in these two outputs, we can see that with invoke SQL CMD, we have a data row. With SQL CMD, we have a string. So this is a key difference between the two outputs and why you would use invoke SQL CMD over the other. By using a data row object, we have a richer, more robust data type that we can work with. In fact, if we look at the whole output using get member, we will see that we have this system.data.data row, and we have methods and properties specific to manipulating the data. What's most important is our columns appear as properties, so now we can reference them directly instead of having to do string parsing to look at specific columns. We can call the name column by simply using dot notation. So dot name for invoke SQL out, and we get our outputs of the columns. So this is how you can query the database in PowerShell, and gives you a lot of flexibility for how you can work with your data once you get it out. The possibilities are endless for how you can manage this, and we'll see some other examples of this as we move through the other lessons. Let's now move on to doing backups. SQL Server backups are an important task, and PowerShell gives us some commandlets to manage backups as well as restores. We're only going to look at the backups for this example. First off, we have a backup SQL database commandlet, and it takes some familiar arguments such as server instance, database that we're going to back up, a backup file, and then if we scroll over to the right, we'll see that there are some other switches such as initialize and copy only that we've come to expect as SQL Server backup syntax. Now I'm going to make the first call using this script parameter because I want to show you something. Specifically, it's this tsql command. What's going on behind the scenes with any of the SQL Server commandlets is nothing funky or amazing as far as interacting with SQL Server, but tsql, pure and simple. We're going to be running this backup database command when we call the PowerShell commandlet. So it's nothing out of the ordinary or nothing complex. Everything we've come to expect when running a SQL Server backup. One thing to also note is that the command also works the same way as other tools that interact with SQL Server. You'll note that this SQL output looks a lot like what you would encounter in Management Studio if you did a script action for doing a backup. If you filled out the GUI, then clicked on script in the upper left, you would get this output. So the other thing to understand here is PowerShell is working with SQL Server in the same way as other tools. So let's go ahead and run our backup, and then we're going to do a directory lookup on that location just to verify that the backup occurred. We get a progress bar indicating the backup action, showing where we are. And now if we do a directory lookup, there's our backup file, just like we expected. Now you're probably saying to yourself, well great, I can do that in tsql though. Why would I need to do this in PowerShell? And the thing is you need to understand that PowerShell is a framework and allows us to do things across multiple servers and with the stack. So I want to show you a block of code here. I'm going to first clean up, make sure that we don't have any files in this C backups directory. So it's now empty. This is where we're going to be doing some work, and what we're going to do is we're going to back up all the system databases across all of our instances into this one location. So this next block of code, I have, as we've seen before, a collection of my servers. So I have an array to work through. And I'm going to do a for each loop. I'm going to go through each of these servers, and the first line is going to get a list of all my system databases using the provider. So I'm doing a directory lookup using the provider and showing all the system objects where system object is true. This gives me a collection of databases to back up. Next, I need to see, hey, do I have a folder for this server instance? If not, I'm going to create that. That's what this line is here for. And then the last line takes the databases, and for each of them, I execute the backup SQL database commandlet and back them up to the folder I just created. So let's go ahead and run this. And now that that's complete, we can do a directory lookup and see that we've created two different subdirectories, so Picard and Riker, and then we have our database backups for each of those underneath. So by using PowerShell in combination with several of the things we've seen already, we can very quickly back up all of our databases to the same location with the same command. What's also nice is if we added another server, or if we had a dynamic server lookup, this block of code wouldn't change. We'd only have to make sure we had the right collection of server names to work off of. As you can see, SQL PS has some powerful commandlets in it that can give us a lot of functionality and flexibility with managing our SQL Server.
So that's the basic use of commandlets. Again, there's a lot of patterns. There's a lot more advanced stuff that we could do with SQL Server's commandlets, but that will get you started, right? That'll scratch the surface.
All right, well, going from there, let's move into our next topic, which is talking about SQL Server Management Objects, or the SMO, or some people call it the SMO. Either way, Mike's going to tell us about it.
Right. So SQL Server Management Objects, rolling back to everything we've been talking about up to this point, is everything in PowerShell is an object. It's not just any object, it's a .NET object. The SQL Server Management Objects, or the SMO, is the .NET library for interacting with SQL Server. Been around since 2002. It's been part of the library for a long while, but it's what you use to interact with SQL Server. Now, the thing I always like to stress with people, again, this comes back to the kind of shared nature of all the tools, is PowerShell is not the only thing that uses the SMO. Management Studio uses the SMO. So the way we're using PowerShell and the way we use Management Studio to interact with SQL Server, it's the same. Everything's built on the same. And there are other tools, right, that they all use Management Studio, or I'm sorry, they all use the SMO to interact with SQL Server. So that's a really important concept for people to get around. Now, when we load the SQL PS module, it gives us all of these SMO libraries. There's a bunch of different libraries, .NET libraries, that get loaded for the SMO. And so the nice thing is we don't have to worry about loading all this stuff. I think, like, if you're a C# programmer, right, you got to include all these different assemblies. Right. With PowerShell, we could load these individually if we wanted to, but really when we type import module SQL PS, it loads all these for us. So we don't have to worry about all of that. And that's it. I think, beyond that, the best way to show people what we're going to do is to show another demo, right? To actually get our hands dirty with the SMO.
All right, let's take a look at a demo on the SMO.
This demo will cover how to use the SQL Server Management Objects, or SMO, within PowerShell. As we've discussed previously, PowerShell is built on the .NET framework, and because of this, we can directly access .NET objects within the language. The SMO is the .NET library for working with SQL Server, and because of that, we can go ahead and create these SMO objects directly in PowerShell to work with them. For example, I'm going to create now an SMO server object. We're going to use the new object commandlet, and then we give it our object type. So in this case, Microsoft SQL Server Management SMO Server. Now when we use the new object, we have to also use any constructor arguments for that object. In this case, the name of the server that I'm going to create the SMO server object for, and it's Picard. So we'll highlight this line and then go ahead and execute it. And now, as with any new object, we'll look at get member to see what our methods and properties are. As you can see, there are quite a few methods and properties for us to reference with this object. And we'll scroll all the way up to the top and see there's our SMO server object as the type, just like we had declared. To examine these properties, we would use the dot notation method. So if I want to look at the version, I'm going to call the server object .version. And this will give us a version object with the major, minor, build, and revision values. Now if I want to see this as if I normally see it in Management Studio, I can just call the version string property, and you can see we get 13.0.1601.5, which is the SQL Server 2016 RTM version. Some basic information that's really easy to access using this dot notation. But we can get deeper. What if I wanted to look at all the databases? I can call the databases property, and by running this, you'll see that we get an output that looks like what we would normally get if we did a directory lookup of the SQL Server provider databases for this instance. Again, stressing that when we use the SQL Server provider or the SQL Server commandlets, we're using the SMO. Everything is working through the SMO. The big difference here is we don't have to specify the force flag because it's not abstracting away the system databases from us. That's an implementation of the provider. With these databases, we can drill a little deeper. So let's say I wanted to look at a specific database, the MSDB database, and a table within it, the sysjobs. I simply have to use .databases, specify within the brackets the item in the collection that we're going to use, and then the same with tables. We'll run this, and then we'll run the get member on that output to see what sort of object we're working with. Again, we have a lot of methods and properties, so we'll scroll up to the top here. And as you can see, we're working with a Microsoft SQL Server Management SMO table object. So we have SMO objects to represent almost anything within SQL Server. All these objects have their own methods and properties as well. So we can look at the indexes property, which is a collection of all the indexes, and you can see that we get the names of the indexes. But this is just what's getting displayed back to us. Each of these indexes is its own SMO object that has its own methods and properties. What's also nice is most of the objects in the SMO have a script method. The script method, if we run it, will generate a T-SQL statement for that object. After running that, you'll see that we get a T-SQL statement to create the sysjobs table. And it doesn't look all that different from if we had done this within Management Studio. Again, stressing the point that Management Studio uses the SMO, and so we can get the same results in PowerShell by accessing the SMO. So this is a handy way for us to generate information. For a practical use case, we can say, well, what if I wanted to generate the logins on my SQL Server? I'm going to go ahead and clean out an old test file here using this statement. And now that I've done that, I'm going to run this line where I take the server object and I look at the logins collection. I take that collection and using the pipe operator, send it to a for each object commandlet call. And what this does is it says, for every object in the collection that comes to me, I'm going to execute this script block. And the script block says, I'm going to script out the current object that I'm on, send it through the pipeline to out file, and write it to this logins.sql file. And we're using the append switch because otherwise each execution would overwrite the file that we're creating. So if we run this and then use Notepad to open it up, you'll note we get a basic SQL script with create login statements for all our SQL Server logins. Now, one thing to call out about this is, and this is just the same as if you did this within the SSMS, for every SQL login, the SMO will actually generate a random password and then give you an alter login disabled. This is a security implementation, so just the way the SMO works, and just something to be aware of, that this password is not actually, it does not relate to the real password in SQL Server. But there are ways to get that and more advanced scripts that you can find out on the internet that will show you how to actually copy the logins with the passwords applied. But easy way to script out our different objects, and we could take this to other objects within our SQL Server. So the SMO is good for retrieving and querying information. What about creating objects within our database? Is it useful for that? That's a little trickier. Let's start out by trying to create a database. So I'm going to create an SMO object for a database, smo.database, and the constructor is the server object that I want to create it on and the name of the database. So we're going to create that and then call getMember just to see what we're looking at. As you can see, we have lots of methods and properties to make use of, and they're all database related. These are all specific to the database that we're working with. As we get to the top, there's our type that we just created. Now what we have is a database object, but a database itself hasn't been created on the server yet. And we can prove that by looking at a directory lookup of the databases on our server. You'll note there's no SMO test database yet. So to create it, we'll call the create method. And now if we do our directory lookup, we can see that we have two databases, SMO test and the wide world importers. So it's real easy to create a database with an SMO object. The thing to understand is we haven't declared anything else about it, and this is essentially like creating a database with all the defaults in SQL Server. As a DBA, I always like to specify names of files, locations of files, and size and growth of files. And we didn't do any of that here. So let's actually drop the database, and we can use the drop method to do it. And now let's walk through how to create an SMO object database using all these declarations. What we first do is we create a series of objects. One for the database, one for the file group, one for the data file, one for the log file. And we have the various constructors for that. For the data file, I then go and specify some other values, such as the physical name and location of the file. I have to declare the size in kilobytes because that's really the only value that it will accept for the SMO. For the growth, we can declare growth type kilobytes or growth type %. I'll then add the file group to the database object and then add the file, the data file, to the file group object. Once I've done that, I will go through the same set of settings for the log file and then add the log file to the database. So let's go ahead and run all that. We now have a database object that we can script out. And this gives us a create database statement that looks like any other create database statement that we'd use in this case. It has the create database, it has on primary, and it has our file declarations that we just specified in the object. And now we can create it using the create method just like we did before. And we can do a directory lookup, and there's our SMO test object with the wide world importers database. So then comes the question of which is more useful to do your database and object creation, SMO or T-SQL. Personally, I like the T-SQL because it's a little cleaner and easier to work with. As you saw, creating a database within the SMO can be fairly verbose with a lot of things to set and configure. So really, it comes down to what your use case is, but I tend to lean more heavily on the T-SQL. And if I need to script or parameterize it, I'll wrap PowerShell around that, but at the core, I'll be executing T-SQL to create my objects. We're going to go ahead and drop that database using the drop method, and this concludes the demo on how to use the SMO within SQL Server and PowerShell.
So that's the SMO, and you really can get down and dirty into the details of working with .NET objects. The provider gives us a lot of stuff. The commandlets gives us a lot of stuff, but if you're limited and you're like, well, I need to do a little bit more, the SMO is your pathway to doing that.
All right, well, let's take this now and get progressively more practical. In our next lesson, we want to talk about using SQL jobs in SQL Agent using PowerShell, and then Mike's going to show us some additional practical tips.
Yeah, so that's the thing, right, is with SQL 2008 R2, they came along and they said, okay, well, we got this PowerShell stuff, so we're going to go ahead and give you the functionality to run a PowerShell script as a SQL agent job. You know, you can do PowerShell as a Windows scheduled task. You can set up other job schedulers. As a DBA, you know,
I like to have it all in one
the
place.
agent's my warm, fuzzy blanket, right? This is what I like to use. I'm used to this as a job scheduling tool. So using the SQL Server agent to run PowerShell scripts is great. Now, there's a couple of things about that. When we do use the agent, it does a couple things for us. So it will automatically load the SQL PS module for us. So instead of having to type import module SQL PS in those scripts, and we'll see how we construct that script and that job step in the demo, but we don't have to do that. It's automatically done for us.
Now, if I did do it, would it throw an error?
It could.
Okay.
And this comes into the gotchas. So there's a couple gotchas with using PowerShell in SQL agent jobs. And the first is with SQL 2008, 2008 R2, and 2012, you're locked to PowerShell 2.0. And that's I don't know really the reasoning behind that. That's just the nature of the beast.
Okay.
But they fixed that in 2014 and in 2016. And again, this is when you're using kind of the client tools. They fixed that.
Right.
So now it will use whatever the current version of PowerShell that is installed in the box is. Now the second is, previous to SQL 2016, the SQL PS module, when you loaded it, would automatically change your directory to the SQL Server drive, the SQL Server provider. And because of that, that could throw some errors if you try to do file system operations.
So if I've got a job that's going to create a date-stamped folder to hold a demo,
Right.
Not hold a demo, to hold a backup, I'm going to need to explicitly switch to the C drive, to the file system.
Yeah, and that's honestly just kind of a good habit. If you're writing PowerShell scripts that execute in a SQL agent job, just do a quick CD C drive at the top, or whatever is an applicable working directory for you, and that'll get around that.
Okay.
It's just one of those little gotchas. And again, actually with SQL 2016, if you have SQL Server 2016 installed, it doesn't do that anymore.
Okay.
They changed that. The SQL Tools team updated that with SQL 2016, and so that is something you don't have to do once you start working with SQL 2016.
Sounds good.
So the way you kind of go about this is, if we look at just kind of the job step properties, right? What we're used to seeing when we go and right-click through the GUI. And there is a way to do this through PowerShell, but again, that's a little more advanced. But if we're just creating a job step, first off, we're going to create a step. We're going to change the type to PowerShell. Simple enough. Now, one thing I like to call out is people always ask about, well, what does this run as, right? And just like any other agent job, it's going to run as the SQL Server service account, the agent service account, unless you set up a credential or something, right? But by default, it's going to be running as the SQL Server agent service account. And that means whatever permissions you need on the Windows operating system that the PowerShell script's going to execute under need to be applied to the agent service account.
And that's always a good argument for credentials anyway.
Yes, absolutely. And then you just paste the PowerShell script into that script window and off to the races.
So from a sort of day-by-day approach, do you find it useful to write the script in the ISE, run it, test it, and then copy and paste?
Bingo. The only gotcha there is the ISE scripts are going to be running typically under my credentials, whereas the PowerShell agent job, and that's something people, just as you're doing this work, kind of keep an eye out for that. If you're you put a PowerShell script into an agent job and it just doesn't run for whatever reason, check your security. Maybe what you're running as and what the script is running as is different.
Sure.
So with that, let's just actually, again, this is something to kind of get hands around and actually see how it's done. Let's actually jump into a demo here and show how to create a PowerShell SQL agent job.
So it's demo time?
Demo time.
It's demo time.
Demo
Let's take a
time.
look.
This demo will show you how to create a SQL agent job containing a PowerShell script. One of the tasks that most DBAs automate pretty early on in their setting up of an environment is backups. Backups are something that we always want to have done and can be a little tedious to do manually. However, one of the struggles that we have with doing backups is there's a lot of file system operations that have to take place in conjunction. We have to have a valid directory path where the backup is going to be made to, as well as we need to have some task cleaning up old backup files. SQL Server can do these, but it's not very good at it. And this is where PowerShell has some real strength that we can leverage. So what I have that we're looking at is a PowerShell script that does backups on all user databases. It does a couple things, and we're going to walk through it. First off, I get a collection of databases using invoke SQL CMD. The query is pretty straightforward, something that is commonly seen, where we're going to select name from sys databases where database ID is greater than 4. The user databases. Once we have our collection of databases, I'm going to create a date string from the current date using the getDate commandlet. The getDate commandlet supports an argument called format, which will allow us to specify the kind of formatting that we want the date to come out in. In this case, 4-digit year, 2-digit month, 2-digit day, hour, and then minute. This will be used within our file name so that we can have a unique backup file for each backup that has the date timestamp in it. Next, we're going to loop through each database and execute a series of actions. The first is we're going to check for a master path that we want the backup into. So we want a separate folder in backup demo for each database that we're going to be backing up. What we do is we create this path, and then we're going to check to see if it exists. If it doesn't exist, which is the not, what we'll then do is create a new directory with this name. Once we have that directory in place, then I'm going to create a file name with the database-the-datestring.bak. I will join both the path and the file name together with this line, with join path, and then we have a full name for our backup. I'll execute backup SQL database against the database with the backup file and a few other switches. And then, once that backup is complete, I'm going to get any backups that are older than a minute ago, so essentially not the most recent backup, and delete them. So in this script, I create any path that I need to back up to, I do the backup execution, and then I clean up any old backups. So what do we do with this script? Well, now we're going to go into Management Studio, and I'm going to right-click on Jobs and create New Job. We're going to call this job Demo Backup Job. And then we're going to go to Steps. We're going to create a new step. We're going to call this step PowerShell script. And we're going to change the type to PowerShell. Now we're going to go back to our PowerShell script. I'm going to select all of it, copy it with Control-A and Control-C, and then we'll paste it into the window just as it is. Once we have this, I'm going to click OK again, and we've created our job. Now before we execute the job, I just want to check our environment to show you what's going on. I'm going to do directory lookup on the Picard server C drive to show you that we currently have no backup demo folder or any subfolders under that. So what our script should now do is when we execute it, it's going to create that folder and back up our databases to it. So let's go back to Management Studio and run our job. We're going to start job at the step, and it's going to execute. So now that it's complete, we'll close it out, and we're going to now run our directory, but this time we'll actually call out backup demo recurse. And as you can see, now we have the backup demo folder, and under it we have a wide world importers folder, the database on the server that we're backing up. Within that directory for wide world importers, we now have a backup file with a unique date timestamp of 2016-06-12-2031, or 8:31 in the evening. It's pretty straightforward, pretty nice. So if we run this again now, because we have that file cleanup, we should still only have one backup file, and it will be the most recent one. So we'll go ahead and execute this again. And now that that's complete, we'll go back and rerun our directory lookup. And as you can see, we now have only a single backup, but now it's from 8:32 p.m. So it's deleted the old backup, and now we have a different one in place of it. So running PowerShell within a SQL agent job is pretty easy and fairly convenient for us to use, as well as gives us the flexibility to work across the stack, not just within SQL Server.
So that's how you create a SQL agent job containing a PowerShell script. It's really pretty simple. There's not really a whole lot to it. But when you do that and you start to use PowerShell, you obviously get access to all other aspects of the Windows platform.
All right, well, we said we wanted to get this module to be progressively more practical. Let's continue that. Mike's got some patterns and some use cases that you might find interesting. Mike?
Yeah. So again, when I talk to people about PowerShell and they're always asking me, well, okay, what's the big deal? I want to say, okay, this is a practical impact that using PowerShell in your environment can have. And for this particular lesson, I want to go over 3 different use cases. There's there's so many. Anything you can automate that works across the stack, PowerShell is a great choice. So getting SQL Server inventory information, right? We as SQL Server professionals, we need to create inventories. We need to know what's in our environment. And I did this a couple years ago at one of my previous jobs, and we had a new COO come in, and when I showed him the output of it, he's like, "This is the most documentation I've seen on any of our stuff in our environment." Nice. So, and it didn't take me that much work. That was the great thing about it, right? You build the script, you run it once, and it just goes. Another thing is, a very simple thing is testing your SQL Server connection. You know, how many times have we had somebody come by to our desk and say, "Hey, I can't execute this query. I can't connect to the SQL Server. The SQL Server must be down." And I'm like, "Well, let's test that out." And usually it's just I connect to the SQL Server and I run a select statement. Well, instead of me having to click through a bunch of stuff in Management Studio to do that, I just have a simple PowerShell script that I run and say, "Okay, here's my server name, bang, go." And I actually, for more advanced stuff, I wrap it up into my own little function and have it as part of my profile. But we're just going to look at the script part of that now. Okay. And then the third thing is whenever we have to restore a database that's in full recovery or in bulk log recovery, right, we have to apply first the full, then maybe a differential, and then a bunch of log backups. And for those of us who are taking log backups every 10, 15 minutes or more, that can be a very tedious task. PowerShell, with a couple lines of PowerShell, I'm able to just spit out the script and get me maybe like 85, 90% of the way of doing that point in time restore. So I can either create the script or actually execute the restore and save myself so much time of doing that. So those are the three use cases, and let's just dive into the demo and see how this all works.
All right, sounds good. Let's take a look at the demo.
This demo will show you some practical use patterns for managing SQL Server with PowerShell. The first example I'd like to talk about is collecting server inventories. Managing large environments, we like to keep an idea of what our SQL servers are, what versions are installed, various information about our SQL Server environment. This can be done using T-SQL and the DMVs, but it can be a little tedious without a good way to execute those queries across multiple instances. We can get a lot of the same information using the PowerShell SMO through the provider. And because PowerShell is built to handle multi-server execution, we can get this information pretty easily across multiple servers. For this example, I have a collection of my instance names, Picard and Riker. I'm going to take that collection, and using the pipe operator, I'm going to send that collection to a for each object call. And for each one of these objects in the array, I'm going to call get item on the SQL Server provider directory for the server. This will get the SMO server object that represents each instance. I then take that collection and send it to a select object call because I want to see only specific properties. In this case, name, version string, edition, and service account. I will then take that output, use the convert to CSV to convert it to a text file. Though instead of using a comma for my delimiter, I'm going to use the pipe character. I also declare no type information because I don't want the type of object that I'm working with to be recorded in the output. Finally, I take this and use the outfile commandlet to write this to ctemp inventory CSV. Now, one of the things with convert to CSV that it does is it writes its files with a quoted identifier. This can be problematic for data imports, so I like to strip it out. This next line is going to read the content of temp inventory CSV, and for each line in there, it's going to replace double quote with an empty string. And then we'll just rewrite the file back out to its same location. Finally, we'll go ahead and see what the output is. So if I highlight this and execute it, you'll see that I get a very simple CSV file with my inventory information. Now, this is a nice pattern because it's dynamic. If our list of instances changes or grows, all we need to do is add a server name to this. We could also use other methods of building our server name collection. We could use a text file that has all the server names in it, or we could use a dynamic table lookup. We could query tables with invoke SQL CMD, and then return that data into a collection and use that for our loop. There's a variety of ways to get this information, as well as we could look at other properties and methods more applicable to what we need to know. At the core, the pattern is to understand using PowerShell and the provider to go across multiple instances to get your information, and then write it to the appropriate output. For the second example, I'd like to take a similar pattern where we're going to check all of our servers in our inventory, but we also then want to see, can we connect to them? Now, the way I usually test connections is by running a simple select statement against my instance. If it returns the select, I know it's queryable. I've had instances where the service is running fine, but I can't query it, and that doesn't do me a whole lot of good, so I always want to test my connection by simply querying the database. So I'm going to take the same collection of instances, though I'm going to add a new one that's not a valid server. This doesn't exist. I then declare an empty return set, an empty array that I'll be putting objects into. I have a SQL statement that's my connectivity test, a simple select @ server name, and the create date of tempdb from sys.databases, because this will tell me when the service was restarted. Then I loop through each instance. The next part of the script is a little more advanced, where we're using a try-catch block, but this is simple error handling and works much the same as it does in T-SQL. We're going to attempt to query the target instance with our simple select. If it returns data, we're going to populate this row object, which we initially set the values to null. We're going to populate it with the values from the query so that we have a valid return for our connection test. If the connection test fails and returns an error, we're going to drop into the catch and not do anything, because we know that this is an empty result set and we want it to remain null. The finally will be always executed, and we'll take the output, whatever it is, and add it to our return set. We'll pull back the return set with a format table call to see what connections are successful and which ones aren't. So let's go ahead and execute this. And as you can see, we come back with a simple result set that says, here's our server name and when it started up. And we know that this connection failed because it has no startup time. So it tells us that this server is either down, or maybe we have a bad server name. Just like with the previous example, we can expand our instances collection to use the same block of code and the same logic to check as many instances as we need. And we can use the same server list if it comes from a text file or a database table, whatever works for us. For the last example, I'd like to go through creating a point-in-time restore script for a database. One of the tricks and one of the more tedious things to do as a DBA is to restore a database to a specific point in time. Because of a full backup, we have to take a full backup. With the full recovery model, it can be troublesome because we have to restore the full backup and then all log backups after that. And if we're doing log backups every 10 or 15 minutes, we could have a lot of log backups that we have to add to our script. This is why I like to use PowerShell to automate this, because it can make the task very easy. For the first line, we're going to get our most recent full backup. We do a directory lookup on wide world importers, where our backup files are, for star.back files. I will then sort the output by last write date time, descending. Finally, I take the first of those, so the most recent file. Next, I will do the same directory lookup, but this time looking for .trn files. I will check for only files that have a last write time more recent than the last full that I got, and I'll sort them ascending by that last write time. Now, we're going to use the restore SQL database commandlet, and it requires a special object collection to move the files. So I create this collection of relocate files for each of my files in my database. Now, there are ways to make this more dynamic, but to keep the example somewhat simple, I went ahead and explicitly declared these. So once we have this information, Then we can create a loop for restore statements. Here I have the database name that I want to restore the database to, and then I have a restore statement for my full, and then 2 restore statements for my logs. Essentially what we're doing here is if it's the last log, we're going to restore it normally, but for all the other logs, we're going to restore with no recovery. For each of these, I'm going to send the output to an out file, temp restore SQL, and then I'm going to append those files. What this does is this actually takes those T-SQL statements that make up the restore and writes it to a file that I can then edit and maybe eventually execute. So let's go ahead and run this. And now with the notepad open, you can see we have a basic SQL file that has all of our restore statements. If we examine these restore statements, particularly over to the right, you're going to see that we have our move statements to relocate our files. So this is very handy, particularly if you want to generate your script and then tweak it a little bit before you execute it. However, let's say we just wanted to restore. Well, then we can go down and execute the same block of code, but this time if I go over to the right, you'll notice I don't have the script switch and I'm not sending the output to a file. So we're going to take that same block of code using all the same objects and run it. And once the restore is complete, we can go to Management Studio, refresh our databases, and there's the database that we just restored.
So those are some practical use cases for PowerShell. Like I said, there's all sorts of things. Honestly, if you can think of something that you have to do a couple times, you can automate it, you can script it, and PowerShell is probably a great choice for that.
All right, well, in this module, we learned a ton about using PowerShell with SQL Server. Let's recap what we saw. So the first thing we learned was that there's this thing called SQL PS. Right?
Yes.
That's
Yes.
the module for PowerShell with SQL Server, and that provides us our SQL Server functions for PowerShell. One of the things that SQL PS also gave us is this concept of the SQL Server provider.
Right.
It exposes SQL Server as a virtual file system, enabling us to essentially drill down into a given instance, into a given database, into a given table, and use kind of a familiar way of looking at it. We also saw that the module included commandlets that were specific to SQL Server, a wide range of them. You said there were how many?
There are 46 commandlets.
46 commandlets. All right, that'll be on the quiz. We also talked about the SMO, the server management objects, the .NET library for accessing SQL Server, and we saw that PowerShell is just one of several peer-level clients that use the SMO. That includes SQL Server Management Studio. That's going to include Visual Studio. From there, we went into looking at how we could run job steps in SQL Agent using PowerShell scripts and integrate that into our existing jobs. And then we got practical. We talked about common uses for PowerShell and SQL Server. Mike mentioned his use of PowerShell to generate system inventories. He talked about using PowerShell as a great way to automate point-in-time restores and do so much of the work that you might have to do to get that long list of full and differential and log backups.
Yeah.
So,
that saves me so much time, man.
All right, sounds good. So that's going to wrap up this module. We'll be back after a break to take a look at using PowerShell with Azure. Thanks. Hi, and welcome back to Microsoft Virtual Academy. I'm Chris Randall. I'm here with Mike Fall, and we're going to continue talking about PowerShell for the SQL Data Professional. And in this module, we're going to go to the cloud. We're going to see how PowerShell can help us with SQL in Azure virtual machines and with Azure SQL Database. So, Mike, did I steal any thunder? Is there anything in the
No. So I think the one thing to talk about is it's important to recognize the cloud and that this is where things are going. This is where much of our computing work is going to get moved to eventually. And with that, I think the best way to manage Azure is through PowerShell. You can use the GUI tools, you can use the web portal, and it's effective, but it can get a lot, you can get lost in the clicking through windows, clicking through sections of it, and you can't automate it. That's the big thing. You cannot automate a GUI, or you can, but it's really, really hard. PowerShell makes it easy for us to do this, and the cloud is about automation. It is about spinning stuff up rapidly and repeatedly. So in this particular lesson or module, we're going to go through 3 sections. First off, we're going to start about how to get connected to Azure. It's the fundamental entry point. We can't do anything with Azure until we can connect to it and authenticate to it.
I'm going to guess we have to import a module.
We have to import, we have to import 2 modules.
2 modules, okay.
So we're going to talk a little bit about that in the first lesson, that there is a difference between what's called classic deployments and resource manager deployments. Then after we get into that, we're going to just go through how to spin up an Azure VM with SQL Server installed on it. The nice thing about Azure and the Azure model is there's a lot of templated machines out there, and there's several templates for SQL Server. So we're going to walk through how we can spin up one of those templates into a fully functioning Azure SQL Server VM. And then finally, so there's the platform as a service. This is the new thing with particularly the cloud, is instead of having to worry about all the infrastructure behind it, spinning up a machine and installing SQL Server, we can simply create what's called an Azure SQL database, which is a platform as a service. When you spin that up, you get the database. You don't have to worry about anything else behind it other than this is the service level. And we're going to talk about service levels and what that all means. But at the end of the day, it gives us an effective SQL Server database without all the other underpinnings that we have to manage. And we're going to talk about how we can use PowerShell to spin that up and manage it.
All right, so you've already kind of hinted at this. We're going to need some new modules.
Yes, so
Stock
let's go ahead into the first lesson here, and we're going to talk about 2 different PowerShell modules. So this comes down to, again, there are 2 types of deployment models in Azure. There's the classic deployment, which is how Microsoft originally rolled out how Microsoft originally rolled out Azure, and was pretty much the way that you would work with it up until, I think, a year and a half to 2 years ago. And then they came out with what's called resource manager deployments. Now, resource manager deployments work a little differently behind the scenes, and it's mostly around this idea that they wanted you to be able to group resources into containers. They wanted you to be able to have everything that stood behind a particular application or setup to be within this one container, so you could manage it, you could spin it up, you could clone it, and there's a lot of stuff around that. And we're not really going to get into that. I just want people to be aware of the difference between these 2. And because of that, we have 2 different modules. We have an Azure PowerShell module, which has pretty much everything to manage anything under the classic deployment model, as well as some additional things. And then we have the Azure RM module. Now, Azure RM focuses on the resource manager deployments. It's still being added to and developed. I want to say it's bare bones. It has everything you need, but for managing some of the SQL components, we're going to go back to the classic deployment stuff, and that's why you need both modules. There are some overlapping functionality pieces to this, but for the most part, you're going to use one or the other depending on what your situation is. Now, to get these up and going, we'll go ahead and take a look at the slide here. We're going to have import module commands, right? So to import the Azure module is to simply import module Azure. But once we've done that, then we actually need to authenticate or connect to Azure. If you go into the Azure portal, you have to log into it. You have to use some sort of account. For a lot of people, it's their Microsoft Live account, but if they're using a corporate account, they'll use something else. So we need to use the add Azure account commandlet, and this we'll see how that works in the demo, but this will bring up something for us to authenticate into. With Azure RM, it's a similar pattern. We're going to use Azure import module Azure RM, we're going to use import module Azure RM, and then we're going to either log in Azure RM account or add Azure RM account. Now, why the 2 different commandlets? I can't really tell you. It's just that was developed, and I think what they did is they created login Azure RM account first, and then came back and said, oh, wait, that doesn't match the Azure module, so we're going to make the add Azure RM account. Anyway,
And so that gets you to the point where you have access to your subscription and the existing resources you have, and then you can start creating additional items as well.
Yeah, absolutely. So that's and that's really the thing to think about this in the two pieces is first we load up all the functionality. So once we import the modules, we have the commandlets to use, but then we have to authenticate to the account. And you could authenticate to multiple accounts. There are ways to manage multiple subscriptions. Really, all the demo is going to show is how to manage the one subscription, but it gets you started.
Sure.
So
well,
with the
let's take a look at a demo.
Let's get into the demos. Let's see what's going on.
All right, let's connect to Azure.
This demo will show you how to connect to your Azure subscription using PowerShell. To connect to Azure, we need to make use of one of two modules. Either the Azure module, which is all the commandlets for managing the classic deployment Azure functionality, or the Azure RM module, which is used to manage anything under Azure Resource Manager. To install these modules to your computer, if you have an internet connection, you can make use of PowerShell 5's package management functionality. From a session that has administrator privileges, you just run install module Azure and install module Azure RM, and PowerShell will connect to the PowerShell gallery, which is online, and download the appropriate code. You'll get the most recent version and have everything you need. I've already done this for this demonstration, so we're going to skip that. We're going to move on to actually seeing what's available to us using get module, list available, and filtering on Azure. The result is a number of modules. If we scroll up here, we can see that they're installed to C Program Files Windows PowerShell modules, which is the default directory. And then we have the Azure module, which contains all the core classic deployment commandlets. We also have the Azure.storage module, which contains all the commandlets for managing Azure storage. Following that, we have many modules for Azure RM. And then we have an Azure RM script. What Microsoft did for the Azure RM functionality is they broke up the different pieces into different smaller modules for easier management. And then we have this master script that if we do import module Azure RM, will load all the Azure RM modules for us. We could, if we wanted, load each module individually, but there's really no need to. To actually make use of these modules, we just use import module. So I'm going to go ahead and load the Azure module using that commandlet. And now that we've imported it, I'm going to connect to and authenticate to my Azure subscription. I'll use add Azure account, and when I run it, you'll see that we get a graphical dialog for logging into our Azure account. I'll put in my credentials, and since I'm using my MSDN account, it will redirect me to a slightly different page. It looks the same and works the same, and once I connect, I have my subscription information that I'm connected to. Now if I want to log into the Azure RM commandlets, I will import module Azure RM first, and then I will use login Azure RM account to connect to that. I'm connecting to the same subscription and I'm using the same credentials. The only difference is we're connecting to a different implementation of the Azure module, so it has to authenticate a second time. Once I've connected, we're actually connected to the same subscription, just in a slightly different manner.
So that'll get you started with the Azure modules, right? We now know how to load up the functionality. We now know how to authenticate to the account. And now we're ready to actually do some stuff, right?
All right, so we've got a way to connect to our Azure subscription. We now need, as SQL professionals, we need to start working with SQL servers, SQL databases. The first thing we're going to look at then is manipulating SQL Server VMs in Azure. So what do we do?
Well, so that's the promise of the cloud, right? Is to be able to spin up infrastructure quickly, to be able to deploy virtual machines in hours and minutes instead of days and weeks. So really, that's where we want to start, because from a traditional SQL Server administrator's viewpoint, this isn't really any different from managing SQL Server on-premise. It's just now the virtual machine is hosted in Azure instead of being hosted locally in some data center. It's a traditional box version, out of the box, off the shelf, whatever you want to call it. And so we're used to using, that's developer, that's standard edition enterprise. Just now, instead of in some data center that we work with, it's in an Azure data center, which really, to be honest, as a DBA, isn't really any different from how I've been using it so far in my career. I mean, the last time I've actually been into a data center has I think, been over a decade.
Right.
So really, it doesn't change from my point of view how we use it. Now, to do this, though, we have to do a couple things. Now, when we would stand up a SQL Server on a new machine in some other environment, like a data center, we would purchase the host, whether it's a Dell machine or an HP machine, and we would pick the number of processors and all of that. The way that translates to Azure is we have a class of machine, a size of machine, and from Microsoft that says, okay, you're going to get this many CPU, you're going to get this much RAM, you're going to get these additional storage features. So we need to decide how big our machine is going to be. Now, here's the good news. The good news is like, if we had bought the machine for our data center, we're stuck with that.
Right.
Whatever we buy, we're stuck with. Azure and the cloud, if we choose the wrong size, we can change it at a later point. So throughout this process, as we show how to stand up an Azure VM with SQL Server, if we choose the wrong size, we can come back and say, okay, well, we didn't get enough CPU or enough RAM. We're going to change that setting, and we're going to change the class of the machine and resize it to that value.
And it's not just about making a mistake, it's also flexibility as the application grows, as the load grows, the number of users, we can scale up, we can scale down.
Yeah. It's one of those that you can't necessarily scale up and down on the fly, as maybe you could with a VMware or something, where you could just say, oh, well, just add a couple more vCPU. But you do have that flexibility to say, okay, well, the application's going crazy. Everybody loves it. This particular widget website that we've created. We need to upsize our SQL Server. It's a very quick operation, and by quick I mean like a couple of minutes, and your machine is resized to whatever you need it to be. And
just to clarify that, you can indirectly add CPUs, add storage, add memory. You just go about it a slightly different way.
Yes.
So you're just changing the overall size of the machine as opposed to adjusting individual sliders.
Absolutely. And what helps with all of this too is Microsoft gives you templates to execute on this, right? So you get a lot of the work stripped out from you, where you don't have to worry about, did I get this patch or this particular hotfix. In fact, that's one of the things that Microsoft offers as part of the virtual machine setup, is you can have automatic patching made available to you. So now no longer do you have to worry about applying Windows patches or SQL Server patches. Microsoft can take care of that for you if you just say, oh, well, enable this particular switch.
Right. And all those switches are exposed to PowerShell.
Right. Absolutely.
Right. And so you talked earlier about the different deployment modes. You've got the classic model, then you've got the resource model. And in talking about the resource model, you mentioned that a resource was a container. There was a container of resources. It was a nice way of keeping things together. So as we go through this, and we talk a little bit about storage, we talk about storage accounts, we talk about virtual networks, that becomes the container for those things as well, right?
Right, absolutely. And that's the reason to use the resource manager deployment model, is because you can then encapsulate that all, and it's a logical container, right? There's really nothing there, enforcing your use of these. It's just, it gives you a good way to logically contain all the objects that you're standing up as part of your infrastructure. And that's really what we're doing, is we're creating an infrastructure. Now, one of the things as part of our infrastructure is we need to figure out our storage. Just as if I'm going to create an on-premise machine, I need to figure out, okay, well, I've got this many LUNs, and I'm going to slice out this from the SAN, and I got to get all this. We need to create storage volumes for our Azure VM. We don't just get fully blown from nothing. We get, oh, here's your VM with all the attached storage. And we do need to take some of the considerations in mind that we would if we were setting up an on-premise SQL Server. So things like 64 kilobyte allocation blocks. We need to make sure our volumes are set the proper size. But once we do all this, once we figure it out, and there are some particular Azure things to take into consideration as well. Microsoft offers standard and premium storage accounts depending on how fast and how well you want your storage to perform. So we need to take these into consideration. This is one of the big design phases.
Well, and to back out a level, though,
sure.
If you're already in an organization that has a dedicated staff at the data center that is essentially handing you a virtual machine as a DBA to manage SQL Server on, that organization is probably going to do this stuff for you as well.
Right.
And the nice thing that we're going to be finding out about PowerShell is that you can mix and match that. You can have the people who know storage and know how to manage the network create that part of the script, and the people who know SQL Server and say this is what SQL Server needs to look like. You can put those together into reusable content.
Absolutely. And what really works well for larger enterprises, larger companies is now you can have a standardized build for what you need,
right.
and you build that into PowerShell, and then again you could say to some engineer, say, please go execute this to create us a new SQL Server as part of our environment, or if it's something that happens on a periodic time frame, or something that you can schedule, you could easily automate the generation of virtual machines and say, okay, well, we need to spin one up and spin one down, so on and so forth. So really, there are 3 steps, though, to kind of keep in mind when we start talking about creating an Azure VM with SQL Server. The first is to figure out what your SQL Server is going to look like, right? So the version of it, am I using 2014? Am I using 2016? Am I using developer? Am I using enterprise? And then how big it is, and then what's your storage requirements. Much the same as if we were going to sit down and say, I'm going to spec out a machine to put into my data center. Now I'm just going to do it on Azure. Once we do that, then we have to kind of allocate that storage space. And there's other infrastructure concerns as well, such as a virtual network, IP addresses. Now, a lot of this, again, would be handled by maybe somebody else, some other engineer, but we do need to at least figure out, okay, what's our storage going to look like? And then it's create the VM. Yep. Then it's just say, execute the VM. In fact, I think the best way to show this is let's just dive into a demo and walk through the different steps here and see how it's done.
So let's take a look at creating an Azure VM with SQL Server in it using PowerShell.
This demo will show you how to create an Azure SQL Server virtual machine using PowerShell. To get started, as with anything with Azure, the first thing we want to do is log into our Azure RM account. To save time, I've already done this, and so I want you to know we're already working in the context of my Azure subscription. The next thing we want to do is set a few values to get started with, and I do this so I don't have to type things over and over again. Primarily, I'm going to initialize some variables for the name of my resource group, the location I'm going to create these assets in, and then a storage account name that I'm going to be using to create my virtual hard drives for my virtual machine. The other thing we need to know for creating a virtual machine is a local administrator credential. Whenever we create an Azure VM, we can create our own administrator credential and have our own login. And this gives us, administrator access from the get-go and allows us to secure it. Once I have these in place, the next thing to do is to create an Azure RM resource group. Now, this resource group is a container. It's going to house all the assets we're going to create. Because we can't just create a VM, we need some other things to support the virtual machine. Now, I've already created this resource group, so I'm just going to step you through the script of the assets we're going to create, and then I'll show you the virtual machine at the end of it. The next thing we need to do once we've created our resource group is create some network assets. We need a virtual network that our virtual machine is going to live in Azure. So the first thing we'll do is create a subnet config that the virtual machine will live within. So I'm creating a subnet, and here's my address prefix for it. So I'm going to have everything 10.0.0. something. Then I can create the virtual network within the resource group and a location using the same address prefix and that subnet that I just created. Next, I want to create a public IP address. When I create my virtual machine, I can create it, but unless I create a public address, I can't access it from the outside world, which is what we want to do. So I'm going to need to create a public IP address with new Azure RM public IP address. Again, resource group name, location that we're going to create it. I want it to be dynamically allocated, and then we need to give it a domain name label. If we don't do this, then the only way we're going to be able to connect is by using an IP address. I want to use a DNS name, and we're going to look at that in a bit, but I want the DNS prefix to be intro-vm-sql. Then, once I have the public IP address, I will create an RM network interface. And what this will do is this gives me the whole network interface with the public IP address living in the virtual network that the VM will live on. So once I have these virtual network assets, I can go ahead and create a storage account. The storage account defines the different parameters around our disks, our virtual disks. How fast they perform, what quality of service we're going to get, where they live, and any sort of caching. So to do that, we create a storage account and we give it a name. So in this case, I'm creating within the same resource group, and I'm going to call it Intro to Azure VM. I declare a type of storage. So in this case, I'm doing standard, locally redundant storage. That's what the LRS means. You have a variety of options with your storage between standard and premium, as well as what kind of redundancy. So locally redundant, geo-redundant, other different types. And then the location I want the storage account to live in. Once I have the storage account, I need to create some paths to my virtual hard disks. These will be created when we create the virtual machine, but I need to figure out where I want them to live. In this case, we're going to be putting them in the storage account, and we're going to need the endpoint of that storage account, as well as then a container called VHDs and the name of the VHD itself. So we're going to have the OS drive be Intro to Azure OS disk, and the data drive be Intro to Azure data disk. Next, we need to figure out what our Azure virtual machine image is going to be called. Now, we can use these commandlets to look up what the image name is, but we need to know three different things: the publisher of the image, the author of the image, and the SKU of the image. If we look at the publisher and filter on SQL, there's a variety of options. But the one we're going to want here is SQL Server, Microsoft SQL Server. Once we know the publisher, we can look at the offerings by using image offer and filtering on the publisher name. And this is where you'll see you have different SQL types and different server types. We're going to go with SQL 2016, WS 2012 R2, so on Windows Server 2012 R2. Then to identify the SKU, we'll use get Azure RM VM image SKU, use the publisher name in the offering, and this will tell us that we have these different SKUs, and we're going to want the SQL Dev SKU. So now we can actually create the Azure VM. We do this by declaring a configuration using new Azure RM VM config. We give it a name and we declare a size. Now there's a lot of different sizes, so pick one that's appropriate to you. I've chosen standard DS1 V2, which gives me 1 core and 3.5 gigs of RAM. Then I declare some parameters around the operating system. I define my image, and that network interface that we created above, this is where I add it to the VM. I set my OS disk to the name and the path that we created above, and then I add the data disk. And here's where I actually declare not only the name and the path, but I need to declare the LUN, the size, and what kind of caching we're going to use. Now we won't talk too much about caching, that's why I left it to none, but you have a variety of options which could help your performance if you had SQL Server running on it. Once I have all these in place, I can run new Azure RM VM to create the VM. Now again, I've done a lot of this so we don't have to wait for the creation of the virtual machine. That can take several minutes. I think when I created this virtual machine, it took me about 5 minutes for it to be provisioned and become accessible. I'm going to go ahead though and run git Azure RMVM on the resource group name and the name of my Azure VM to show you its existence. So it's up, it's in this location, this resource group is where it lives, and its status OK. Now that we have an Azure SQL Server virtual machine, we can go ahead and connect to it, and we'll just use remote desktop to do that. And I'm going to run that with this invoke expression. Now that we have this come up, we can log in using our credentials, and this is that credential object I created earlier. And now we're just in a virtual machine. It's a Windows machine just like any other, except now it's running SQL Server and it's already installed for us. Now before we get to SQL Server, there's one other thing I want to talk about, and it's that data disk that we attached. Just because we attach the data disk doesn't mean it's usable. So I'm going to open up PowerShell. You can obviously do this through the MMC if you wish, but I want to show you how to do it with PowerShell because this is an introduction to PowerShell. We're going to copy these lines from the primary script because these are to be run on the virtual machine, and what we're going to do is configure and format our new volume. So first off, if we look and do a git disk, we're going to see several different disks appear. Disk number 0 is our operating system disk, and this is, we can't configure it. We did set it as part of the image, but there's no configuration we can do around this. It's just given to us by Microsoft. Disk number 1 is a scratch disk provided to us by Microsoft as well. This is temporary. It gets rebuilt every time you restart the virtual machine. Don't put anything permanent on this scratch disk. Then finally, disk number 2 is the data disk we added, and it hasn't even been partitioned. So this is the thing we need to do, is we need to first initialize it. So that's what the initialized disk will do. And now we have the partition style of MBR. Next, I'm going to create a new partition and give it the drive letter of F. I'm going to use the maximum size allocated to it. And there we go. But the last thing we need to do, just like we would have to do with any other drive we're attaching, is format it. So we're going to use the format volume, call the drive letter, give it a file system, a label. Now, this is SQL Server. I want to format this for SQL Server, and it's important that we do this with the 64K block size. By default, it would be 4K, so that's why I'm setting my allocation unit. And then just because I don't want to answer any questions, I'm just saying confirm. Don't ask me to confirm my choices. So we'll run this. And now we have a formatted data drive. So this is something that needs to be done even if we're creating new VM. No matter how many data disks we're attaching, no matter how many data disks we're creating, the Azure Virtual Machine doesn't automatically format them and attach them for us. We need to do a couple additional steps. So now with that, we can go ahead and open up SQL Server. We'll open up Management Studio, which is by default already installed. And you'll note that it comes up with a connection to the machine name. We connect to it, and we're logged into SQL Server. We have our build number, which is the RTM release of SQL 2016. And other than that, it's just a SQL Server installation. The one thing to call out is you'll notice I used Windows Authentication. That's because by default, our local administrator account that we created is added to the system administrator role on our SQL Server installation. At this point, we have a fully functioning Azure VM with SQL 2016 running on it, and we can go ahead and start creating databases and tables and store procedures and whatever other SQL Server objects we want.
So as you can see, you can create an Azure VM with SQL Server on it with PowerShell. There's a bit of verbosity to it. There's a lot of different steps, but once you have it scripted out, it's repeatable and easy to do.
And that's kind of the point of all this, because we want to be able to scale this across as many VMs as we need to get the job done. If we're dealing with availability groups, we want to be able to get that reliable and repeatable.
Right.
So we want that same approach that we would take on-prem, but now we can do it in the cloud. Right.
Right, exactly. But we can simplify it. We can definitely simplify things if we wanted to use the platform as a service offering, the Azure SQL database, because this takes away a lot of the components that we're used to having to manage. A lot of those things that we had to declare for the Azure SQL VM, we don't have to.
So let's talk about how to manage Azure SQL database using PowerShell.
Right. So doing this is, again, this is kind of the way I think to do it. There's a lot of there's not as many components to manage. In fact, like here, this particular slide here gives you a quick overview of what Azure SQL database, all the different components. Now there are less here to worry about than with the Azure SQL VM, but these are all manageable through PowerShell. So we can create things like the server that's going to host our Azure SQL databases. We can create the individual databases and the firewall rules. So this is all. And again, the idea is that we have this automated process. I'm finding actually in a use case that we have right now where we have a particular database that we spin out for a client. We want to use the same database every time, so we script it in Azure SQL database and just push it with PowerShell.
Sure. So, I mean, if for the purposes of this course,
right?
What's the difference between SQL Server and an Azure VM or Azure SQL Database? For the purposes of this course, there's not a lot of difference because we can get at it, manage it, drive both. Now, from the perspective of a customer or a learner, yeah, there's going to be a difference. One of the things we talk about is if you are migrating an existing application, you might want to use SQL Server in a VM. If there are particular features that you're taking advantage of that are provided by SQL Server's full capabilities within that VM, you stay with the VM. If you're focused primarily on the core database engine, you might look at SQL Database. But again, our key thing here is it's all the same to PowerShell.
Well, yeah, it's all the same to PowerShell, and in a lot of ways, it's all the same to SQL Server DBAs.
Right.
I mean, at the end of the day, you have a database, and the beauty of it is, and this is actually, I think, some of the things that database administrators sometimes struggle with, right? Is there's a lot less we have to worry about managing. There's a lot less that we have to worry about controlling and setting up and configuring. And for me, that's liberating. I'm going to go back to, I'm a lazy DBA. That's why I like to use PowerShell to spin this stuff up. And the thing I like about Azure is it takes away a lot of these concerns for me. So with that, let's just show how easy it is. We'll jump into a demo here and show how you can use literally just, I think the script is maybe 10 lines long when you look at the whole thing to spin up an Azure SQL database.
Sounds good. Let's take a look at the demo.
This demo will show you how to create an Azure SQL database using PowerShell. Since SQL Database is a platform as a service offering, it's actually a lot simpler to create it than to create an Azure VM hosting SQL Server. As with the Azure VM, we do want to start off by logging into our Azure RM account. Now I've already done this to simplify things, and we'll just move on to the rest of the script. The next block is where I declare several variables so I don't have to keep typing things over and over again. I start off by having a resource group name, which will be Intro Azure SQL. I have a location of West US where I'm going to create my Azure SQL database. My server name is MSF-SQL Intro, and my DB name is MSF-SQL Intro DB. Now, because I need to create a firewall rule to my current local IP address, I'm using this REST service call, so invoke web request, and the URI of the web service, and this gets me my local IP address. Once I have that, I'm going to create a credential object with my SQL administrator credentials. These credentials are essentially SA for the server, but we can call it whatever we want. So we'll go ahead and execute this initial block, enter in the credentials, and now we'll go ahead and we're ready to begin actually creating the objects. First, we need to create a resource group to hold all these SQL components. We'll create it with the resource group name and the location that we declared in our variable area. Don't worry about the warning. This is just Azure alerting you to some changes that might be coming in an upcoming release of Azure. But this is all we need to do to create the resource group, which is essentially a container to hold all of our objects. Now we're ready to create the SQL Server. So I'm going to run new Azure RM SQL Server. I need the resource group name and location where I want to create the server, my server name, my administrator credentials, and then finally the version of this Azure SQL database I want to use, which in this case is 12, the most current version of Azure SQL database. We'll go ahead and run this, and this actually will create our server. That is all it takes to create the actual server, but keep in mind we still don't have our database yet. We simply have a server that can house multiple databases. Now we'll go ahead, go back to the script, and now I want to create my firewall rules. I'm going to use the new Azure RM SQL Server firewall rule to create the appropriate access rules. And the first one is to allow all Azure IPs. What this means is that by creating this rule, anything that is within the Azure boundary, any sort of Azure service, can connect to my Azure SQL database without me having to open up any additional ports or IP addresses. The next rule will actually create the firewall rule for my location where I'm at. We're going to give it a name, and if we go to the end here, you can see we have a start IP address and an end IP address. And this defines the IP address range that I want to declare the firewall rule for. We'll go ahead and execute these two rules, rule creations. And now we have our firewall rules created. Now remember, we can create firewall rules specifically for the Azure SQL database that we're going to create as opposed to the server firewall rules, but for simplicity's sake, we're just going to stick with the firewall rules we've created. Now we're actually ready to create the Azure SQL database. I'll use new Azure RM SQL database, give it a resource group name, the server name I'm going to create it on, so this has to exist before we can create our database. Database edition, in this case standard, the name of our database, and the requested service objective name. This is the service level we're going to create our database at. S0 is a pretty standard way to go, good way to start, but remember that we can always change this after we've created the database. I'll go ahead and create the database now by running that line. And there our Azure SQL database is created. And that's it. So now that we have an Azure SQL database, let's go ahead and connect to it. To simplify things, I've created an expression for the SSMS command line execution that will connect to the server I just created. So server name.database.windows.net. We're going to connect to the master database, and I'm going to use the credentials that I created, and we'll just go ahead and open up SSMS with that. So now that Management Studio opens up, our Object Explorer actually looks only a little different. We have our connection string at the top, and we have a databases folder is the only thing we can look at. If we open this up, you'll see here's our Azure SQL database, which we can then further browse into, and now we have nodes that we're used to seeing in Object Explorer and Management Studio if we're connecting to an on-premise version. At this point, we're working with a SQL Server database. So we can go here and change our database context from master to MSF SQL Intro DB. And now that we've changed it, we have the ability to run any sort of SQL query, create tables, create store procedures. It's just a database at this point, and we can do all the things we would normally do in a SQL Server here.
So that's it. That's really all you need to do to spin up an Azure SQL database with PowerShell. I like it because it's a whole lot less complicated than the Azure SQL VM.
Right, right. All right. Well, in this module, we took a look at using PowerShell in the cloud, but to manage Azure SQL databases or to manage SQL Server VMs in Azure. Let's take a recap and wrap up our course here. So in this particular module, we took a look at the fact that there are two different deployment models. There's the classic model, and then there's the resource manager model. And one of the benefits, of course, of the Azure RM or resource manager model is that you get this container for all of the assorted objects that also need to get created if you are working with Azure, especially with VMs, where you've not only got the VM itself, you've got storage, you've got virtual networks and IP addresses. And so having that resource group can be great for being able to clean up quickly when you're done. We also took a look at provisioning and deploying SQL Server in a VM using PowerShell. And the key thing there was once we got that VM up and running, it was just like any other Windows machine that we were administering with SQL Server running inside it. And we used our familiar tools to do that. And then we finished up to take a look at using PowerShell to deploy an Azure SQL database. And we saw that there was probably 99% of the things that we needed to do could be done with PowerShell, with the exception of getting that initial server firewall configured. Then we had to use the portal for that because we didn't have a way to address it. At least that was the way when I learned it. Has that changed?
Yeah, that's changed.
We can do that with PowerShell now?
Yeah, actually.
I need to hit the books.
Yes, yes.
When I
watched the demo.
Well, I probably got to go back and watch it again. Yeah, when I first learned this stuff, there were some steps you had to do first in the portal, but I've been schooled.
Yeah, well, and that's the thing I think to stress is, the cloud and Azure is constantly evolving.
It's a moving target.
It's a moving target, and the things that are, if you're having struggles one day, 3 months later, I wouldn't be surprised if Microsoft has implemented that. In fact, Microsoft's been very responsive with feedback that they're getting about Azure and improvements that they're making. So keep an eye on what's going on and just stay educated. All right.
Well, that brings us to the end of our Microsoft Virtual Academy course on PowerShell for the SQL Data Professional. Thanks for watching, and check some of the additional resources that we'll provide in the MVA console. Thanks.
Thank you.